nanotechnology initiatives on the continent. We know, for instance, that as part of the AU's Science and Technology Innovation in 2016, they inaugurated the high-level panel of African emerging technologies, and pursuant to that appointment, we know that one of the flagship projects, of course, is the promotion of nanotechnology. Now, I think, as many of you are aware, there's a lot going on in the continent, but we thought that it would be important to highlight the need for a cogent policy framework, which can obviously guide the ethical promotion ethical promotion and application of nanotechnology on the continent, and also ensure that the policymakers are able to provide the adequate institutional and political support that is that is necessary to catapult the African continent into the fourth industrial revolution. So we hope that with this this is the first step in this endeavor, and that we hope we'll be able to as more and more people become aware of this AMRS initiative, we're together with UNECA, we'll be able to attract more policymakers and a greater interest, and hopefully make an impact in in the realization of the formulation of a comprehensive policy. So that's what I'll say. Having said that, I would like to now proceed and introduce our first speaker for today, and that is Professor Martin Thuo. Professor Martin Thuo is a professor of material science at Iowa State University. It's a position he has held since 2014. Professor Thuo has been doing a lot of work around the issue, I think, of he has done a lot of work on the physical organic studies of surface and interfaces. He has also focused on the idea of electronics. I think in particular, his emphasis or his focus has been on the idea of the construction of flexible electronics, and I think their contribution to, I think, what he quantifies as the understanding of quantum tunneling in biology. Professor Thuo has also published extensively, having been a postdoc at Harvard University under the tutelage of Professor Daniel Quinn. So without further ado, I would like to leave the floor to Professor Thuo to lead his talk. Thank you.
Thank you very much for the kind introduction. And if my voice is a little bit sore, it's very early here in the morning, but I hope that the message comes through. And I'm very impressed by what AMRS is trying to do. And my talk here, I hope will be a catalyst towards that effort and towards pointing to the possibilities that the continent can realize. So what I wanted to share with you today is something that has been sitting on my mind in the recent past, and if I can manage to push these away, on this idea of microelectronics and where we are going with microelectronics. And there's a pending revolution in how we do this. And so it's going to be a little bit technical and a little bit social science. It's more of a talk on the problem of or the opportunity in microelectronics, what some of the potential solutions are, and what my personal opinion is about where Africa stands in this, and then I'll end with a very, very brief conclusion. So to get us started, microelectronics have been driven for the longest part, for the last probably like 50 years or 60 years by the so-called Moore's law, where we see that the number of components in every device have been doubling every 2 years. And we've gone through 24 such doubling. But if you look at what we have been able to achieve, when you think about the Pentium 4 and the i7 chips, we're getting to a point where we're hitting the computing capacity of the mouse brain. But this has been driven largely by the fact that we can scale things down. We can get things smaller and smaller. We can pack more components per square millimeter than we could when we started out. And if you look at for example, the Intel chips from 1971 to 2018, the number of chips you can get there is in the billions, and this has doubled 24 times, and the time to double has only been 2 years. However, if you follow that very closely, you realize something else is happening, that the doubling is kind of leveling out. And the reason it's leveling out is that I don't even know why we call this microelectronics anymore, because the components we are working with here are already at the nanoscale. So it's in fact, we are working with nanoelectronics. But as you start getting into the single nanometer scale, the space becomes too limited. And you have to have different ways of fabrications. You have encountered new challenges in scaling it down to be able to get higher packing as we have always gotten previously. So if this idea of having the computation power of a brain is going to be realized, then we cannot just scale our way out. And this problem of scaling out is actually complicated by the fact that we have to think about how we're going to do the manufacturing. And as we get smaller and smaller, the question becomes, are we getting towards single molecule devices? Are we getting to atomic level components? And if you get to that level, how do you start manufacturing a large scale and with high accuracy using the tools that we have right now? Then the traditional fab lab becomes a problem, and it's not going to be sustainable. Another problem we see with scaling, since we have become so device dependent, this idea of packing more and more processing power has driven our hunger to consume more of computational capabilities. Our phones are more powerful than the computers that send us to the moon. But if you look at the innovation coming out of scaling down, we cannot keep up being equally innovative by basically cutting down the size of the devices we are making. And in fact, if you look at the relative performance improvement by just scaling down, you see that once you hit a device of 90 nanometers and below, that scaling is not a winning strategy. It's not a winning argument. Space is not going to be the winning argument. We can pack a little bit more. We can have a little bit bigger space. But when you get this small, you're not scaling at that point just to gain space. But and we ask ourselves, why is that the case? The reason is simple, that the potential gains due to scaling down are not, in terms of device performance, are not equal to the cost that is associated with that. The lithography, the tools you need to manufacture devices at this level are very, very advanced, very complicated. And Africa may feel that microelectronics are out of reach. But I would like to actually challenge everyone to think about what this means in terms of the future of electronics, and we will explore some of the future options in a little bit here, and we will see how this is being leveled up and how Africa can come into the picture. So as I mentioned, we've been scaling down. We started with silicon has been the go-to material for this. We started in the early this century. We started working with strained silicon. We started going to high K metal gates. And then we have entered this age of what is called the hyperscaling, when we're going to below 10 nanometers and getting into single nanometer components. But there's a problem. As we continue to scale this, once you get into the 10 nanometer, how much can you double the size or scale down the size of your component before you start getting to under 1 nanometer or 0.1 nanometer, which is the size of an actual hydrogen atom? Can we actually then, at that point, be able to make a hydrogen atom a transistor or a computational component? From basic chemistry, that tells us that it's not going to be possible. And so we have to think about other approaches to be able to pack so much computational power we cannot just go down by hyperscaling. And the other thing we also need to think about is that when you're doing this kind of scale down, the more you scale down, the more expensive you get, the more complex the devices get, the more cycle time gets, the more sophisticated the tools, and the more the analytical methods you need, and very specialized methods you need to analyze devices that are sub 10 nanometers. And of course, the more resources. You may get a very, very small chip, but the background of that is that there's so much support system, there's so much power associated with it, there's so much processing associated with it, that that device, although it may be small, is not that cheap. So we need new solutions, we need new ways of thinking. But is scaling down the only problem we have with the current trend in microelectronics? If you look at how much we moved from something like a 90 nanometer device all the way to even a sub 10 nanometer FinFET, it's been pretty rapid and pretty quick. But is scaling down going to be the only problem? Are we getting to a point where we can say there's no more space down there, like Ferment told us? So if we think about the scaling and the march towards the single molecule and the sub 10 nanometer component, we still have another problem. As the devices get smaller and smaller, as we make these components more refined, if you look at the power per process that is used by this microprocessor, is about 1,000 times to 10,000 times higher than the brain. How come that these machines are so small and yet an organic material, something that is made of things we normally consider to be non-conductive, is consuming so much less power compared to what we have made? And the other problem we have is that based on the advances in computation and the demand for computation capabilities, we're going to get to a problem with the power. Those of you who are following things like cryptocurrency, you know that sustaining one Bitcoin is consuming a huge amount of power. And the question is that kind of computation even possible? And if you look at the trend in the computer energy that you need per year versus the maximum that we can produce, you realize that by 2035, we will hit what is called market dynamics limit, meaning the amount of energy we can dedicate to our devices is going to hit a maximum and it has to protrude. So if we continue scaling down and consuming this level of power consumption, is going to be unsustainable. And so advances in computation capability will be limited by the supply in energy or in power. And so we need another pathway. And this is from the recently published SRC Decadal, where they say that unless we find a new pathway to ultra energy efficient devices, the current trend is not going to be sustainable in less than 15 years. We will be hitting the limit. And just to further illustrate this, to illustrate the need for these very high efficient devices, if we take some things that are already being developed, if you look at a supercomputer, and we like to use these supercomputers because they're very efficient in data processing. But if you look at how much power you have to consume for each one of those supercomputers, then it gets to a point where you're spending 29 milliwatts of power to just run one of these frontier Cray Shasta computers. And if I take, for example, a country like Kenya, this amount of power is all that Kenya gets from, it's more than what Kenya gets from wind energy. And so if a country in Africa has one of these supercomputers, or even 2 or 3 countries come together and get one of these, the power demand is going to be a little bit unmanageable. And so we have to find new solutions because we cannot be generating power just to sustain the computers that we have. And another question we also need to ask ourselves is, as we go into more and more data processing, is it necessary? Is the data actually important, or should we develop new technologies where we do the so-called edge computing, where you pre-process the data at a point of collection and you dump out what you don't need. You classify the data and dump out any low information density data and only transmit to the central server what is actually needed. So we need new paradigms in how we are doing our computing. Just harvesting data and putting it in these giant servers is not going to work. And so as we think about chip manufacturing, if you take even the cross-section of, this is an example of a chip on iPhone 5, you can see it's already very, very complicated. And we ask ourselves, if these chips are so complicated, how is Africa going to compete in this space? Is there even a chance that Africa can be competitive in the microelectronics? Well, if we follow this paradigm, the answer is no. However, if we think about the fact that these chips are becoming a little bit challenging to manufacture this scale, this line here is about 1.14 nanometers. So these are really, really tiny components. Then and this is something I borrowed from Professor Shakar from Harvard, where he makes the case that Moore's law has given us 24 doubling. If we continue scaling, we only get to about 27 before we start getting into problem with the surface area to volume ratio. The surface will dominate the performance of the devices. And then what we can do, we can get into what is called the chemical time scale or the biological time scale, or we can update that by going into multidimensional interfaces as our computational component, and that will give us about 43 times doubling. But then if we go to atoms, single atoms of inorganic materials, we'll get to about 79 times of the doubling. However, look at this. If we go to organics, we're in about 100 times doubling of the components since the initiation of Moore's law. But if we go to self-assembled biologics like proteins and DNAs, that is where we get the ultimate computational capability. So actually, it turns out the future is in more soft matter-like components. It's not the traditional crystalline material, because we will be working with a single functional group or a single molecule to be the transistor or the computational component. And when I saw this, for me, this is good news for the continent of Africa. We have a lot of people who are in this area who can do a lot of work here, who can actually help move this transition away from Moore's law into a new form of computational devices. So I see this as a reset button that allows the African scientists who may be disadvantaged by current lithography to jump in and be more creative and push that forward. But how do you do it? The first thing you need, if you have a new challenge at hand, you need to get the right skills. So that means you need human capital. And for sustained growth, you have to actually recruit people across the whole growth curve. Those innovators, those creative people, the transition people, and the stabilizers of whatever innovations you will have. So what this calls for is some level of cognitive diversity. And to get that cognitive diversity, you can use tools like the so-called AEM cube, which identifies and beams talents based on the skills a person has, whether they are more attached to the past or they are more future-looking, whether they are more attached to the material or the matter space or the human space. And you can feed these into different components of this growth curve. And so at the end, what we're looking for skills. We're looking for new capabilities, people who have different ways of solving problems. And so in my own thinking, what I would give as my unpopular opinion is that what Africa needs and AMRS can do is to assemble skills, not credentials. Get the right skills, not pieces of paper, not what somebody has and can put on the table and say, I have these many degrees. Start looking for talent beyond the academic pipeline. There are people who actually are very good or are very experienced with working with biologics, but they may not have the PhDs, but they have years and years of working with biological molecules or electronics. And then we need to, of course, address cultural issues, things like bias, gender bias, tribalism, and neocolonialism. And I'm going to share a few examples that are going on in Africa, in America, that we can draw parallels from on how we can actually improve the workforce. And those are coming from some work that is being done at Harvard where there's a move towards pushing for what are called looking for stars. And stars are people who are skilled through alternative routes, who are not following the traditional ways. And I can imagine Africa is full of people like this, people who are really good in a certain area, but they may not have the bread and butter qualifications to stand any chance of participating in this evolution. And so if we look at the US, for example, the realization that is going on in the US is there's a lot of people who have gained experience through their workplace. They are more in the trade. And so in this op-ed and in the NBER working paper that came from Professor Blair's lab at Harvard, they observed that there are more than 30 million American workers who don't have a degree, but who have the skills to get them into even higher levels. And I can take this statement here and replace it for Africa. Instead of workers, I can put scientists. I can replace the new jobs to engineering and technology. There are so many people who are qualified in the basic sciences, who have a lot of skill and know-how to play in the space I just indicated, who can open these new technologies and new capabilities for the continent. However, because of the background, because of the degree they hold, they're actually not even eligible to participate in something that looks like engineering or innovation. The other thing we have to do is to address cultural issues. And if you learn from the US, as most of you know, has been dealing with recent issues of racism. And this is a precipitation from the days of slavery. And so I argue that Africa must also contend with the colonialism and neo-colonialism, in fact. The idea of the African big man, the idea of social structure, those are barriers towards realizing the true potential of the continent. And the other thing is the continent has to realize is we have to get everybody involved. We must tap into 100% of the population, and that means overcoming gender bias because women as creative as men in any space. And so what we need to think about is we need to think about how we hire for skill and work experience and not a degree. Look for these talented stars and enable them and give them the platform, invest in them, and actually build them up instead of relying on traditional academic qualification to do that. And why do I make that case? Because I believe for us to play in this space here, we cannot just limit nanoscience to materials. We have to go to our colleagues in biochemistry and molecular biology, in computational biology, and our friends in chemistry and physics and mathematics. And the beauty of Africa right now is that there's high mobility between these professional disciplines, and it's easier, therefore, to integrate these tasks. And if you look at this trend here, the future looks more integrated and interdisciplinary than the traditional way of thinking about this being materials dominated, electrical engineering dominated, just nanoscale fab dominated. It needs to be a little bit more diverse and more integrated. The other thing that Africa has an advantage for is that if you look at the top 10 youngest country in the world, they're in Africa. A place like Nigeria and Somalia, about half the population is in the very early years. You know, the median age in Africa is 19.7 years. And in terms of human talent, we have about 1.4 billion people. That's 18% of the world population. Almost 1 in 5 people live in Africa. So it indicates that the potential in terms of brain power is very, very high. It just needs to be tapped. The other thing I want to point out is that if you look at the continent of Africa, is way much larger than we see depicted in maps or we tend to think about. Africa is 3 times larger than North America. So not only is there a huge human capital, there is also natural capital in the continent. And so the question I pose is, can African nanoscientists lead by using these unique tools to engineer the future? Will new paradigms emerge that are not even being predicted by Western scientists? You know, can we think about this crisis and give it an African take to it? And I'm very inspired by mobile banking in Kenya. You know, when it was introduced, the mobile phone, the M-Pesa, there was so many articles written on how it would never work, but somehow the the ingenuity of the people and the demand and the need that was there made it work very well. And the other thing is a historical perspective. If you go back in history and you look at when there was demand for cars, when the transportation was changing from horses to cars, America came up with the idea of an assembly line, and they improved how they can make these cars. And when they that very simple rope and a winch that was introduced in Ford Motor Company became a huge thing that changed the whole world. So sometimes the simplest ideas revolutionize the whole world or the regional economies. If we take an example, after the assembly line, if we take now the example of the Asian tigers, the 4 Asian tigers, Hong Kong, Japan, Taiwan, Hong Kong, Taiwan, Singapore, and South Korea. They started very simple. If you look in the 70s, some of these economies were at par with African economies. But what did they do? They moved into supplying the world with electronics, and that enabled them to emerge as one of the richest regions in the world outside the traditional industrial centers of Western Europe and North America. And this was driven in large part by the evolution in microelectronics. So I pose the question, is Africa going to be the next to benefit from this? Will Africa benefit from bringing new, unique nanotechnologies into the world in a way similar to what the Asian tigers did? And to give you an example, sometimes when we see things like this, we say sometimes we don't have the resources. Well, the assembly line was very simple. It was a winch and a rope that allowed Ford Motor Company to produce thousands of cars with a very small workforce. And this is old. It's 1901, 1904. But now things are complicated. We don't have the resources. We can't do it. I want to give you an example of something that was very revolutionary, but it took very little technology. If you take the fabrication of electronics, we have been using solder for more than 5,500 years. And this solder was invented in 3500 BC and was used to make pipe ducts in the Roman Empire. Even when we invented this transistor, the way we build those interconnect, we used a technology that was developed 3500 BC. And there was one major problem with this whole process here. We were using lead-based solders, and they were very toxic. So we ended up here at Iowa State, one of my colleagues, Professor Ivan Anderson, developed what is called lead-free solder, the stuff that is in our phones, in our computer, in our electronics. Every one of us has a piece of Iowa State in their hands. And that solder solved a 5,000-year problem because lead is toxic, and we know that it can be a problem. But notice that after the lead-free solder was developed, the low-temperature solders took less than about 20 years to come into play. And heat-free solder that allows you even to build circuits on soft materials and on leaves and on flowers, on any soft matter you can imagine, on brains, was developed very, very quickly. So sometimes a trigger, a problem, it becomes a solution that spurs a lot of innovation. And you ask the question, how is heat-free solder being developed, and what is the relationship with the nano? It turns out that this is driven by large part by a very, very thin 1 nanometer shell in which you put the metal and you prevent the metal from solidifying. How do you manufacture it? You don't go back to the traditional sort of manufacturing processes. You don't need atomizers. You actually need something as simple as a blender, a shearing equipment, and you have yourself a heat-free solder. So if Africa thinks outside the box, if Africa defies the traditional pathways, then there is likelihood to get some very, very new technology. And I can give you more examples if we had time. And so in conclusion, I take this example of a heat-free solder development and lead-free solder development, a very quick jump. And I want to point to you that every challenge or crisis is someone's opportunity to shine. Is it time for Africa to shine? Africa's nanoscience is growing and has great potential. Are we going to welcome these organics and self-assembly processes that they eliminate the fab labs or they minimize the need for the fab lab, and we start now bringing new capability to the fore? And the other thing that Africa has, and it's very encouraging to me, is there's a lot of human capital. And whenever you have such large number of people, statistically, you have a lot of smart people. the percentage, if you put a Gaussian curve on it, you will definitely have a lot of very, very gifted people in there. And the other thing too is that there are a lot of people who are still comfortable with frugal innovation. They're not, their thinking is not, I want to use the word corrupted by the presence of technology. So they can think from a very MacGyver type approach in their thought, and therefore amenable to come up with solutions that will challenge the existing paradigms. And with that, I want to say thank you very much. And I hope that we can continue this discussion to the next stage. Thank you.
Thank you very much, Professor Thuo, for that illuminating discussion. Certainly, I think most of us who were listening to your talk, are really fascinated by it. I think for us, just also coming to understand, just the amount of power that is expended in trying to produce, these electronic devices. I mean, I think that is really quite thought-provoking. But also, I think your solution, I think what you impressed upon us, the need for us to invest not only in our human capital, but actually to go beyond the realm of academia. I think that is actually, I think that is also something that is quite refreshing. I think for us, as we look at what's been happening with social media, we look at, or even just generally at Microsoft or Apple, we come to note that all these entrepreneurs, many of them either were dropouts or they did not complete their, they didn't go to university. So again, I think that is an important point. And again, in terms of just also transforming our own mindsets with regards to that. So I'd like to thank you for that. And I think when we go to the panel discussions, I think, there'll be a lot of questions to follow. I think now we'll proceed, I think, with our speakers. I think I would like to call Professor Winston Wole Soboyejo. I don't know if you are ready, Prof. Soboyejo.
Yes, I'm ready.
Okay. Thank you.
Thank you. Thank you very much.
Can
I share my screen? I hope.
Yeah, please go ahead. You're enabled.
Okay.
Thank you.
Yes. Yes. I'd just like to introduce you, Prof, for some of our panelists or some of our attendees who may not, be familiar with you. Professor Winston Soboyejo, Professor Wole Soboyejo, should I say, is the provost of the Worcester Polytechnic Institute. He's a professor of mechanical and aerospace engineering, and he's also pretty much a renowned material scientist and engineer. Between 1992 and 1999, Professor Soboyejo was an assistant and associate professor in the Department of Material Sciences at Ohio State University. Professor Soboyejo has chaired the African Scientific Committee and of the Nelson Mandela Institutes, which was founded with the mission of bringing excellence in science and engineering to sub-Saharan Africa. During his time there, amongst his goals was the establishment of a network of Pan-African research institutes modeled on the elite Indian Institutes of Technology. So in addition to Prof's distinguished career in the area of science as well as engineering, Prof is very well steeped actually also in the world of social sciences. He has also helped to develop the Center of Global Public Policy and Safety. So with those few words, Prof, you've got so many accolades. I could go on forever, but I think to allow you time to make your presentation, I'll depart from there and allow you to go ahead and make your presentation. Thank you.
Thank you. It's a pleasure to be here and to have this opportunity to share some perspectives, especially on the role of materials and nanotechnology in policy development. And I'm going to share some personal experiences with you as somebody that's been trying to do science and engineering, and also connect to policymakers in ways that translate into practice and impact. So if you look at the history of the world, you find that science and technology and innovation are the engines of development. And this is apparent in Europe, North America, and of course, with the most recent development of Asia and the BRICS. The key variable is the number of scientists and engineers per million people that you have. Typically, you need over 1,000. Africa has about 83 scientists and engineers per million people. So we don't have the critical mass. You also need to invest about 1 to 4% of your GDP in research. And the key research to invest in is materials. And if you look at that, you realize that many of the innovations that I show here are driven not necessarily by electrical engineering or mechanical engineering or biomedical engineering, but truly by materials, the enabling science that enables a lot of these technologies that I showed to happen is materials. And that's why I pursued a career in materials. And that's why all of us, I think many of us here, really have come together around the importance of materials and especially nanoscience and technology at this time. And there are lots of things that you can do into sort of many, many different fields, some new, some old, that are critical for development of our society. So about 20 years ago, I was invited to a workshop that was organized in South Africa by the NRF and the NSF, the South African National Research Foundation and the US National Foundation. And basically this brought together many scientists from across the world who wanted to really do science in collaboration with Africa. I was a scribe at that meeting, so I wrote down many of the things people wanted to do. And subsequently, I organized a number of other workshops to really crystallize out those ideas into strategies for action. At that meeting at the Farm Inn in Pretoria, the idea of an African Materials Research Society was born. And we subsequently started working towards the establishment of this society. And I have to tell you, it was not an easy process. Lots of people had different ideas about what the society should be. In the end, we came up with the idea of making it a network that promotes collaboration, that promotes capacity building, that promotes research, that can inform policy in Africa. And since that time, I have tried to leverage this as a platform to really try to think in a Pan-African way. The founding fathers of the African MRS at that time, including prominent scientists such as Frank Nabarro of South Africa, who is a well-known materials person to most of us in the field, Professor Olusegun Adewoye, who, like myself, graduated from Cambridge many years ago, but really a leading materials figure for Africa. And folks like Yunus Balam from South Africa, who became our first president. Abubakar Beye, who organized our first meeting in Dakar. And Joe Zimba, a future president of the society. Said Kanai from Algeria, who was there at the beginning, Abdulaziz El Jazuli, and others. And this group basically worked hard to establish a society and build an ethos. And what we wanted to do was to develop an African materials network that would use materials to develop the resources of Africa. And we decided, due to limited resources, to have biannual meetings, engage policymakers in the development of our capacity in materials, and engage industry in the development of materials and value addition, whilst leveraging international collaboration and partners. And if you actually look at this resource map of Africa, which is only a subset of what we have, you realize that Africa is rich in materials. Now, from those early days in the early 2000s, it's interesting just to see what this interface with policy could enable. So as a result of our collaborations with the Nigerian government, they established a Nigerian Nanotechnology initiative as early as 2004, 2005, which sowed the seeds for many things to come. This was led by Professor Adewoye in Nigeria, who was a member of the government, who was able to work with President Obasanjo to drive that initiative. And then the interactions with UNECA started. I remember going to Ethiopia to interact with Grace Opoku to talk about how we should also engage this in a policy framework. Later on, I had some opportunities to interact with the United Nations and the World Bank, again, trying to promote research and an investment in graduate education and research, not just the sort of initial focus of the World Bank, which had been on primary and secondary education. And this led to the desire of the World Bank, for example, and other stakeholders to develop what are now known as the Nelson Mandela institutions. And in that process, I found that we could bring the materials network, many of whom became members of the African Scientific Committee, to advise the World Bank and the African governments on how to really establish these centers of excellence, which are now real and existing in Africa. Now, a lot of our interactions happened around meetings across Africa, from the first meeting of the society in 2003 in Johannesburg. We have essentially rotated across the different regions in Africa in a way that has enabled this network to stay together. And what we have done as a community is also, with the support of the National Science Foundation in the US, to kind of focus our efforts on human needs. And so we've taken our focus in materials and applied them to problems in health, to problems in water, to problems in energy, to problems of infrastructure, and to creating a network, which is an eclectic network of physicists, chemists, biologists, engineers, and some policymakers, in a way that makes it a very healthy group, and also leveraging international collaborations with the US and other places to really build capacity. One of the things that was funded in the early days is something called the US Africa Materials Institute, which brought about 100 African scientists to the US to learn techniques and to establish capabilities that they took back to Africa to build the labs. And these are some of the people that came. Motiti from Uganda, Makerere University, Grace Oparide, who came from Obafemi Awolowo University, and people who came from more than 30 African partners to really learn techniques that they took back to build the field from the early 2000s until about 2010. Now, at that time, one of the things that I started to notice was that actually we needed to do more to build real capacity on the ground. And I was inspired really by the Indian Institutes of Science and Indian Institutes of Technology that had been established by Nehru at the onset of the Indian independence. And I would argue that these institutes, in some senses, are the foundation of a lot of the development that India has had since its independence. Not only have they impacted India, they've impacted the world. If you look at these institutes, they've produced more CEOs of global companies than any other set of institutes in the world at the moment. So the question is really, how do you take a country like India, which at the time of Nehru, in a city like Bangalore, looked like this, and transform it, Bangalore and places like this, into a place that looks like that, okay? And so the idea was to establish our own African Institutes of Science and Technology with the idea of leveraging these through our partnerships into something that would transform Africa. And this led to an interaction with political figures that could drive policy and change. And I just shown here pictures of people that we interacted with as we went on this adventure. Jim Wolfenson was the head of the World Bank, who basically asked the African heads of state what was the single thing Africa could do to promote development. Sitting in the audience was Nelson Mandela, who said, invest in science and technology, which for a lawyer is a totally amazing response to have this clear insight on what was needed. As a result of my interactions with the World Bank, I found myself presenting to President Olusegun Obasanjo in Abuja the idea. And in less than 10 minutes, this leader basically decided to dedicate 240 hectares of land and $40 million to create the African University of Science and Technology. Similar things happen in Tanzania, where President Mkapa, who's now late, was approached by Hippolyte Fofak of the World Bank. And he again dedicated initially 5,000 acres of land in Karangai, and later a place in Kamatek to create the Nelson Mandela African Institute of Technology. And after he left office, President Jakaya Kikwete of Tanzania made sure that this happened. And then in Nigeria, Ngozi Okonjo-Iweala of the World Bank became the board chair at AUST, along with Franny Luatia of Tanzania, who drove the processes. And Philip Griffith and myself provided academic advice from Princeton at the time. And so these are the folks who then worked together to make these AISTs possible as our own version, as our own efforts to build on the materials network that gave significant advice to the establishment of these institutions. So these are now real and existing. The question is, can we leverage them in the same way that India has her investment in its own IITs and IISs? And I just want to give you pictures of this. Here's a picture of the African University of Science and Technology. This is the outcome of the investment that was made. It has educated over 200 PhDs that are now working in African universities, but the capacity to do more is there. What is special about those PhDs is many of them are hired in Africa, and they are doing world-leading work in Africa, publishing in journals such as Nature. And they are also doing work that is impacting development, which I will show you in some of the next slides. Now, similar things have happened in Tanzania, where the Nelson Mandela AIST is now real. In our vision, we saw this as the Silicon Valley of Africa, nested between Mount Meru and Mount Kilimanjaro in a very beautiful part of Africa. The dream of this place was that the science and research that is done in these places, in this place, would eventually create a biotech industry and frontier nanotech industry in ways that people like Hulda Swai are making real today. And if you look at the campus, this is a beautiful transformation of what was a very rundown Kamatek Center for Agricultural Machine Technology, which was transformed into this. And I was totally delighted to participate in the meeting of the society that was held here in Arusha in 2019. So the Materials Network at its base, in its role in working with governments, in working collaboratively with scientists and engineers and policymakers, played a significant role in providing some of the backbone to some of these initiatives. Now, what's interesting is we got to do the science. And so in the early days in the 2000 arena, many people argued that we really didn't have the capacity, except for perhaps South Africa, to really contribute to nanoscience. And so we chose to work on nanoparticle research because we knew we could make them. We could chemically synthesize them, control them, design them in ways that could be done in labs across Africa. We also worked on biosynthesis of particles in ways that we could control. We could control their morphologies, their sizes, their properties in a way that could be enabled in an Africa that was there. And we could also train people to do research on how you induce tumors in ways that address the second biggest killer of Africa people, which is cancer. And so by pulling all of this together, we really then started to study the receptors that are overexpressed on the surfaces of cancers that are experienced by Africans. And we found that there are certain receptors that we could target, which will then enable us to design targeted nanoparticles and targeted drugs for the detection and the treatment of cancer. And what came out of this was work that enabled us to target LHRH receptors and other receptors using magnetic nanoparticles that enabled enhanced contrast. It also enabled us to take cancer drugs, such as paclitaxel and prodigozine, and start working on ways of doing biosynthesis of the drugs. And then by targeting those receptors, we're able to show that we can shrink and eliminate tumors when you use targeted drugs. And so this work, which was started and grown in Africa, is now continuing. And we're actually now looking at bigger animal studies and potential human clinical trials as an example of how African research can really contribute to real solutions, in this case, resolving the challenge of cancer in African women. We're doing the same thing, by the way, in prostate cancer, cervical cancer, and also in brain tumors, where again, by studying the tumors that exist in African people, we can target those intentionally with drugs that we can synthesize and molecular methods that we can control. Now, in the same way, we've looked at the challenges that we have in energy. And as we look at those challenges, they're associated with the fact that not only do we lack electricity, but we also lack enough money. So the solutions have to be scaled by technologies we control. And across much of Africa, we don't have light at night. But if you look at many of those places, they have significant amount of solar irradiance. So that we see this as a map of possibilities that has then guided efforts for us to get Africans involved in making solar cells and light emitting devices and controlling some of the nanotechnology that you need to control the sources of light in ways that have resulted in nanoscale control of photonics and in ways that have resulted in solar cells with efficiencies that are approaching world record efficiencies. Again, some of these papers have been published in good journals that basically bring teams of Africans together to do work. And I just want to highlight the recent work on perovskite solar cells that basically showed that by controlling some of the nanoscale layers and in situ diffusion processes, we could make solar cells with efficiencies of about 23.5% in perovskite solar cells. And what we're again doing is now focusing on how do you transition this to technology? What do you need to do to stabilize the devices and increase their efficiencies and do things that transition these from ideas to reality? And as you do this, we also do studies and we promote efforts that will take these kinds of ideas into the community and to apply these kinds of technologies to rural people in ways that make the technology real. And I think this is important as we think about nanotechnology, to really think of it in terms of how it drives the needs of people. This is a case here where solar energy is being used to power refrigeration systems for the preservation of vaccines, for taking medicine and vaccines to rural communities in Kenya. Now, as we think also, we have to think about the applications. And nanotechnology to generate light can fuel then applications in electronic textiles and many more applications beyond what we have today in ways that Africa must connect to. We must connect to the markets, as the earlier speaker said, and we must also connect in many senses to the Sustainable Development Goals. Now, for me as a scientist and an engineer, it was really humbling to be invited by the UN Secretary General to sit on the Scientific Advisory Board of the UN Secretary General. And there I found that evidence-based policymaking can actually provide the framework for the development of the Sustainable Development Goals. And it was very intriguing to see how Ban Ki-moon, who was then the Secretary General, took the advice from the scientists. And at that time, I and one other person represented Africa to really then frame some of the ideas that went into the most recent versions of the Sustainable Development Goals. This is just the Scientific Advisory Board of the UN Secretary General. It included many Nobel laureates and representatives of the different parts of the world. And it was intriguing to see how the perspective of an African materials researcher was actually useful in framing the problems, at least from an African context, and how that got translated into practice. So I think that as we look now at these Sustainable Development Goals, we should also think about how UNECA, and how nanoscientists and nanotechnology policy can address these human and environmental needs. We have to connect then to what I call purpose-driven nanotechnology that identifies the big problems of Africa, focuses on ways of advising how we structure demand-driven group activities that can truly have local impact as well as global impact if we really design these right. So we go back again to this idea, looking at our needs in health, water, energy, sustainable housing, amongst others, and really leveraging the power of the African Materials Research Society, which includes very strong African researchers and international collaborators such as Paul Weiss and Eric Garfunkel, into a network that can help us to take nanoscience and nanotechnology and apply it to health, energy, water, agriculture, infrastructure problems that people can see. And this must always be driven by the science. For example, in our work on nanoparticles, we use this idea that receptor-mediated endocytosis enables you to target receptors that viruses use to get into the cells. You can use the same ideas to develop targets of different kinds, like nanoparticles or drugs, that enter the cell and do different things depending on your strategy. And in the same way, you can use the same to target ACE2 receptors associated with COVID-19, right? And by doing this kind of work, you can now start looking at what are the things you can take into the body. Are they drugs? Are they nanoparticles? And what are the strategies that you can use to leverage our capability to make these things in a way that allows us to make targeted drugs for enhanced lung imaging or perhaps even treatment. And so as we think about this, we've taken these ideas and we've developed nanoparticles now for targeting ACE2 receptors, for enabling enhanced lung imaging that enables you to do COVID-19 detection. And by combining this with robotics technology, you can now use these to do scans of the body. And you can also use these now for diagnostics in ways that are now being done collaboratively with a number of materials researchers in African countries, and also with an NIH-funded grant here in Worcester. And not only do you do this work, it has to translate to practice. And so we're now doing ethical trials of these methods at the National Hospital in Abuja. Now, finally, before I finish, I just want to highlight the fact that we're in the era of the fourth industrial revolution. And what that means is that we should target this nanotechnology in a way that leverages the opportunities that are provided by this era of the Internet of Things and the Internet of Services. The question is, how do we bring Africans together to really leverage these opportunities just as others have done in earlier stages? So I think the African Materials Research Society, for me, has been a network of scientists, engineers, and policymakers that have worked together to establish institutions, that have worked together to build a field of materials. But I do not yet think that we have realized our full potential in formulating an African strategy for nanotechnology. The key thing is we need a holistic approach, and we need to focus on how we go from ideas to markets to ensure that we have the right level of focus and seriousness to succeed. When you look especially at the Eastern countries, their motivation for doing this is purely economics. And in our case, we often see this as intellectual curiosity or efforts by a small niche. We also have to turn this into the science that drives our economies in a way that is also purpose-driven, meaning we focus on our needs, we focus on the market drivers, and we create an ecosystem that is needed for the sustainability of these efforts. And I think that we can motivate some of what we do by the Sustainable Development Goals and the emerging opportunities in the era of the fourth industrial revolution. So it's a pleasure for me to see this workshop between the UNECA team and the AMRS team. And I just want to express our commitment. We look forward to working with you in using nanotechnology as engines of African development. Thank you.
Thank you so much, Prof. Wole-Soboyejo, for your comprehensive presentation. In fact, your presentation, I think, highlights or is at the crux of the current objective of the workshop. I think it, it has actually also shown us, I think your presentation, by showing us what is possible, by giving us the example of the technology institutes that were promoted in India and the possibility that lies for us here in Africa, and how nanoscience and an investment in nanotechnology, nanoscience writ large can actually benefit the continent, and particularly in targeting our our key challenges in as far as the SDGs are concerned: water, health, the energy security, and all of that. So thank you so much for that. I have no doubt that several of our participants would want to actually tap your brain later, both in the panel discussion and beyond. And I think that will be that will provide that opportunity. So thank you again, Prof, for that. And we look forward to more of that. I think if you'll excuse me now, I think we can proceed. I don't know if Professor Hulda Swai, are you available, Prof, to make your presentation?
Yes, I'm available.
Okay, excellent. I'll just start with a brief introduction. I think Professor Hulda Swai is also a nanotechnology scientist. Prof holds a PhD in biomaterials from Queen Mary College at the University of London. In February of this year, 2021, she was awarded the Kwame Nkrumah Award, the Kwame Nkrumah Award, a competitive regional award given to females who have excelled in science. In October of last year, she was awarded the Oliver Tambo Chair in Nanotechnology in relation to biomedical health, sustainable agriculture, after a very rigorous competition of senior African professors. This program receives funding for 5 years up to the tune of $1 million US. Prior to that, in 2019, she was awarded as head of the PI Incubation Center, namely Data-Driven Innovation and Incubation Center, I think the DDI. I think this center addresses food and nutritional security in the region, and she was awarded this after a very stiff competition. Prof. Swai also has many accolades and awards to her name. I would love to, give a full account of all of them, but I think I'll be holding Professor Swai back from actually making her contribution today. So with that, Prof, I would like to welcome you to make your presentation, and thank you once again for participating.
I think it's good afternoon here in Tanzania. I wonder whether you can see my presentation. Can you see it? Hello?
Yeah, if you can just go on the slideshow.
Yeah, I think if you put it on the slideshow.
It's on the slideshow. I'm here with my computer. Can you see it now?
Yes, it's visible now.
So am I audible enough? Hello?
Yes, ma'am. We can hear you.
We can hear you. Yeah, you're audible. Yes.
And can you see me as well? No. Okay.
We can see your slides.
But you cannot see me. Okay. Anyway, I would like to apologize for the delay this morning. I was called by Vice Chancellor on an emergency meeting, so it's delayed a little bit. However, I would like to thank the organizer of this webinar. It has been very inspiring, and I've learned a lot. My presentation, I wanted to present more on nanotechnology, but or nanoscience. Nanomedicine actually is my profession, but a lot has been said. So I'll present more on innovation, and I'll touch a little bit towards the end on nanotechnology. As you see before me, the slide is on Nelson Mandela and Nyerere. This is exactly what Professor Wole was saying. So I don't need to say much. They're the one who are behind the formation of the Science and Technology Initiative for Africa. And this kind of institution, they only take masters and PhD, and they're supposed to work on demand-driven and take the economy of Africa to another level. And that's what they're supposed to do, but we'll see how far we've done on that. And this came, can move the slide? I want to move to the next slide. Okay, before you, there's a slide here which showing us that much as we are well populated, but when it comes to patent and tertiary education, we are actually disappearing. So Africa has got so much natural resources, but we don't have the human capacity, critical mass to harness what we have. As such, this is what you see here, the slide before you. You can see that DRC is among the richest country in natural resources. DRC is number 9. So it's on the League of United States and the like. But DRC, that's Congo Democratic Republic, is the poorest country in the world. So one wonders, how can one have so much natural resources and become the poorest? Or how comes a country like Singapore or Japan with hardly any natural resources, but they are the richest countries in the world? And we realize that what we're lacking is critical mass, human critical mass to exploit or to harness the natural resources we have. So I thought my presentation would be based on that, and then I'll bring nanotechnology. And this nanotechnology is a technology which I'm sure we are not going to miss, like we missed the quantum dots and other things. But with this one, we believe that we'll be able to leapfrog and learn from others and from people like Professor Wole just giving us presentation, and others who presented yesterday, and move to another level. Mandela started, Nelson Mandela, and we were not doing as well as we were supposed to be doing. So the World Bank announced a call for Center of Excellence in Africa. And I applied for one and I got it. It's a project worth $6 million. And when Bella Bed, the lady you see here, came to Tanzania to open the Center of Excellence, he said that for a country to industrialize, you need at least 20% graduates. And in Tanzania, he said, the case of Tanzania, we are only 5% graduates. So she was saying there's no way we can industrialize like that. And here I'm just want to showing that even the 5% we are talking of, they're most collaborating with the Western. When you look at Africa here, you can hardly see Africa and Africa collaborating. So we've been collaborating with America, Europe, and the like, and we've been actually working on the agenda. Most of us before were funded by Gates Foundation, Wellcome Foundation, and the like, and we're hardly funded by our governments. As such, we are working on somebody else's problem, somebody else's agenda. So our African agenda is actually in the back of our mind, and we're not working on it, and we're calling ourselves professors. We are invited all over to present, but we are presenting something which is not touching the community. So the Center of Excellence was started just because of that, so that we can be able to actually address our burning issues. So the objective of the Center of Excellence, which was funded by the World Bank through government loan, through World Bank loan, but through the government. So we were supposed, this Center of Excellence was supposed to focus on training, applied research, that's demand-driven research. We're supposed to look into incubation. So we just don't do research for the sake of research, but we think of what is the outcome, what will be the product. So it's from ideation commercialization. That's how we're supposed to think. And then we're supposed also to do outreach, because most of the work we do ends up in our labs, end up in our computers. It's not actually affecting the people who are in need of it. So we are now seriously doing the outreach, which was not very much favored. And we've started the incubation center, and all this is new. So there's a lot of struggle, but that's the way to go. Otherwise, university becomes like a white elephant. You invest, but people around you, for example, we went to a village around us here in Nelson Mandela, and you were telling them, I mean, this person had a very big farm, and we told them we can assist and advise him on the pesticides he's using, all the soil. And we were surprised, and why should you do that? We told him this is what we are supposed to be doing, and he was just laughing. So we come and invest, but a laughing stock, because we're not impacting anything in our community which is surrounding us. So that has got to be the thing of the past, and our people should see a university as where to get knowledge and where the problems can be solved. So we have to be relevant to our communities, and that's the way we will be even proud of ourselves that we are able to showcase. So we want our PhD and masters, instead of ending up with a thesis or a PhD certificate, to end up with incubation. Like here, you can see that they're working on their prototype, they're working on the incubation. So that's what I've started here. So everybody who is coming to do a PhD should think of a final product, or should actually discuss with industry, community, or the government, and see what is needed. So that research has to be demand-driven and not research for the sake of research. So this is a new thing, so nobody's very excited about it, but we are forcing it so that people don't do research just to get a PhD and then go back in the office and do the normal job, and maybe get even promoted to be a director, while the community has not even felt their presence. So that's what we are doing. And we believe these people will be job creators rather than job seekers. As you can see now, they will end up with a proper industry. So when we tell them that we are here as a scientist, but you might end up being a billionaire owning your own industry, they get excited. And we've got a special training on call it Bush, which is business school or School of Humanities. So they are trained for 2 weeks on how to patent, how to commercialize the products, how to incubate. So they become a different kind of graduates looking forward into being effective and even become rich in themselves. So I also wanted to show us, to take you through why sometimes we are not able to come up with the products. For example, it's very easy to get funds here from universities, from even government. But when you come with almost a prototype, the funds ends up here, because here you need a lot of money, you need the private sector, you need the industries, you need the public-private partnership, and that's where we all end up here. So like here in Mandela, we've got a lot of products in the shelves up to now. So we're actually thinking of going and looking into the products we have and see how we can now take them back and look for sponsors to help us to incubate them. And that will be the private industries, which actually in Tanzania, we don't have many. So it's something which you cannot do as a country, maybe as a region or as a continent, because these products is somebody's used his intelligence for 3 or 4 years, but then it ends up in the shelves. So the problem is, I mentioned, is funding. And another problem we have in Africa is we don't have postdoc programs. The PhD holders, they are busy doing their PhD, but if they stay for 2 years doing postdoc, they will be able to actually move that product from a prototype or from an ideation, actually a prototype and perhaps a product. But wherever I go, even with the World Bank, when I talked about postdoc programs to be empowered or funded, people were not very enthusiastic, and I don't know why. But in Europe, I believe that where we worked in Europe or South Africa, postdocs are the one who actually are coming up with products. Postdocs are one who are collaborating with industries because they know what they're doing, and most of the time they've got the products. So that's one thing I wanted to bring up. And also state-of-the-art labs. We don't, as a country, for example, in Tanzania, cannot have a lab with everything. So we need collaboration of international level, in continental level, so that we can be able to access the instruments we need, because most of the equipment, especially nanotechnology, are very expensive. When you talk of SEM, IFM, TEM, they're all very expensive indeed. So collaboration is the key in all this, and we need to take it as a continental level or regional level rather than a one-to-one case. So just example is if there was more funding. So when there's more funding, you can see things are different. And of course, things like the regulatory system is also a problem. So when we move the industry, like the person who was presenting on from Singapore yesterday, he was saying the industry in Singapore is very close to that university. So the industry, like we were saying, like Rolls-Royce is in the university. So when the industry is in the university, working closely with the university, there's a very big advantage of them picking up what is good, or even influencing the university to do the research which is actually needed by the industry. So this kind of scenario is what one should be looking for, where the industry is a part of the innovation. And of course, industry sometimes they cannot do basic research, but university, we are good in basic research. We are good into prototype. Then from there, the industry can take over. So that is the best scenario one can think of. So now I just want to quickly to talk of nanotechnology, but for me, I'm going to base on herbal medicine. For example, in Tanzania, there's so many herbal medicine. For example, if we've got 556 tribes, and in every tribe there's a cure for malaria from a herbal medicine, a herbal tree, or from some grasses. So all these drugs which are available locally, but they're not packaged, they're not science-driven, nobody can actually use those drugs. So they're used locally, but nobody can export them. But in India and China, you get all these products well packaged with the science driven into them, and they're approved, they're accredited. So we can actually even export them and take them without worrying, because you know what they are, what they're containing, what is the active ingredient. And the old term award I got, I want to use it, just work on the herbal medicine, which has been proved potent, but cannot be used. For example, there are these two drugs here, which have been proved to be very potent, but when they're taken by human beings or by mice, the system, they're destroyed in the system because of the enzymes in the liver or enzymes in the stomach. So if we encapsulate them with less lipid nanoparticles, we believe they can be able to go all the way to the bloodstream. And these are anti-malarials, and actually they're very good for multi-drug resistance malaria, which is very difficult to treat, but they are very good in vivo, but cannot be used because of the toxicity, solubility, or the being destroyed by the enzymes in the liver. So these two products, I'm going to encapsulate them and you come with drug out of them. So this is an Oliver Tambo Award which I applied, and my main theme was to use nanotechnology in health and agriculture. Agriculture, I'm talking of biofertilizer, biopesticides, I'm talking of by plant growth, and all this will be bio, because we've got a lot of bio products around us, but they're not packaged, they're not science-driven and nobody can actually export them. So I want to take you quickly to the a slide whereby I talked about the Old Tambo Award, and after that I will just conclude. Let me just take you through the slide. My name is Professor Hulda Shaidi Swai. I'm a professor in nanoscience here in Nelson Mandela Institute of Science and Technology, Arusha in Tanzania. It is a great honor to receive the Oliver Tambo Award after very stiff competition involving 50 very senior and distinguished professors in Africa. I'm excited to be one of the 10 professors, and indeed this is the highlight of my profession. My main aim of this research is to use nanotechnology to develop new anti-malaria drugs using the potent herbal extract as well as the existing malaria drugs which has poor bioavailability. Nanotechnology will address all the shortcomings. Malaria is one of the world's deadliest infectious disease. Around 2 million people are infected every year, and 500,000 die of malaria each year. Sadly, 90% of the death occurs in sub-Saharan Africa, and a child dies every 12 seconds. Let me repeat, a child dies of malaria every 12 seconds. Currently, there's no effective vaccine for malaria. The earliest drug discovered for malaria is quinine, which was discovered in 1820. But this drug has shown a lot of side effects and is not popular anymore. The successor was chloroquine. Chloroquine was very potent for years, but it has now already suffered resistance. The parasite is resistant to chloroquine, so chloroquine has been withdrawn. Presently, Artemisia, a herbal compound, is the only potent anti-malaria drug. However, resistance has already been reported in Cambodia and Southern Asia. In summary, all anti-malaria drugs available today are challenged by poor bioavailability, short half-life, and toxicity as well. As such, there is a need of addressing these shortcomings as well as developing new anti-malaria drugs. Nanotechnology has revolutionized medicine due to its ability to improve the bioavailability of this compound by increasing solubility, reducing toxicity, and improve dose and dose frequency. This technology will enhance research towards the development of novel anti-malaria drugs from both potent isolated herbal compounds as well as existing drugs which needs optimization. Nanotechnology has been used to revolutionize anti-cancer drugs with very exciting results. A number of cancer drugs could not be commercialized because of shortcomings. But with nanotechnology, these drugs are on the market today as we speak. My research will actually involve encapsulating both anti-malaria compounds based on herbal compounds and also the existing anti-malaria which are lacking potency into nanocarriers of nanoscale. Being nanoscale, they can cross all the biological barrier and be able to get into the bloodstream. And moreover, we can actually target these nanocarriers into the disease cells. For example, in malaria, we are talking of red blood cells. So we can target the red blood cells with nanocarrier encapsulated with anti-malaria inside. This will be a good opportunity of developing a product, commercialize it. For the first time in the region, we will be able to come up with our own anti-malaria drug and save millions of lives. The project will also expand the infrastructure, also build the critical mass which is lacking in form of PhDs and masters in nanoscience and nanotechnology, which will be able to take this technology to another level and in a way will sustain the technology. This is in line with the AU agenda of 2063. We are very passionate on this. Great things are coming. Just watch the space. Okay, that is that. But to be able to do such a project, we need a lot of collaboration worldwide. We need UNECA and other African bodies, because the money they gave us, they actually told us it's supposed to be seed fund. It's $1 million US for 5 years, and they might extend up to 15 years. But it's supposed to be seed fund. We're supposed to take this money and actually attract others, convincing others to come in on board and help us to build the critical mass, maybe open the labs for us, help to supervise masters and PhD students. And that's the only way we can come out of this, because we don't expect the Europeans and the Americans to actually come up with anti-malaria drugs. These are our problems. These are our issues. We should work on them. We can just see how quickly it was to come up with a vaccine for COVID, and it has taken a century for people to come with a vaccine for malaria. So we should take a note on that and take this on board and take it as our own call, and that's the only way we can come out of this. Thank you very much. I hope I was clear enough. Thank you.
Thank you very much, Prof. Huldaswai, for that very incisive presentation. I think your presentation, also kind of reinforced the presentations of both Professor Wole and Professor Thuo. I think in particularly focusing on this notion of the need to invest in our human capital, in our human resources, but also the idea of having an interdisciplinary approach, and also the idea of, I think, trying to sort of harness local sources of funding. So I think the three presentations essentially have, driven home those particular points. So I'd like to thank you for that. At this particular point of the program, I think what we are going to do now is we are going to proceed to our panel discussions. Now, the panel discussions will be combined with the Q&A sessions. So I think as our first panelist, I think I understand that Dr. Owusu is not available. So I'll call upon Professor Shaban Said Khalil. I believe he's available. So Prof. Khalil, you have the floor. Yeah,
Thank you very
I'll allow
much.
you to make your presentation. Yeah.
So maybe we can start with some questions and answers from our great speakers before we proceed further. So please, if you have any questions or comments, I saw that we have about 43 participants, and I'm sure some of them may have some questions.
Yes. So I think the floor is open. I think we can do that and take a round of questions before we proceed. So our attendees, even any of our panelists who have any questions to ask, you may please go ahead.
They have the chance to talk, or they should write the question in the chat?
They have, I think they have the chance to talk, or they can actually write them in the chat, depending upon which one they feel comfortable with.
Okay.
Just raise their hand and then we can enable them to talk.
Yeah, Yes, they can raise their hand and you can enable them to talk.
So nothing, everything is clear.
Well, I think if I may go ahead and take the initiative, and I think I'll put a question, I think, to all three of our speakers, and this, I think, has to do with the issue of promoting political will. I think one of the things that is clear from us, and I think that has come out from the presentations, of course, is this idea of this disjuncture in terms of the level of, should we say, commitment. I think, be it in the form of investment, or be it in the form also in terms of proactive action in trying to formulate a policy. How do we, at this particular point, given the fact that our needs are well known, and the fact that we're on the cusp of this, this fourth industrial revolution, which has many benefits for Africa, how do we deal or address this challenge of political will? How can we begin to generate it? Of course, the policy conference is trying to link to that, but I think just in general terms, how can we begin to to tap that, to address the issue of generating political will? Thank you.
If I may, can I say a few words here?
Yes, please go ahead, Prof. Wale.
Yeah. So one of the things that I found is that it's very important for us as scientists to build relationships with political types. And in all of our systems, there are political leaders that really do want to see progress, but often the language we speak doesn't connect to them, and the timescales we promise are not political timescales. So I'll just give you an example. I've had the great honor of working with President Obasanjo in Nigeria, right? What I find is he loves science and he's totally committed to it. But often when you talk about science that doesn't impact the lives of people, he knows politically it's not something he can sell. On the other hand, if he gives you an opportunity to do something and you do it, and it translates into practice, that is his greatest joy. And the same was true for Mkapa in Tanzania and Jakaya Kikwete in Tanzania. So you have to build relationships with the political types and then have projects that work in a timescale that they can deliver, right? And I think what we need to do, for example, in this era of the fourth industrial revolution, is to craft a strategy that leverages nanotechnology and materials into a Pan-African initiative that we can deliver. And it means leveraging the diaspora, leveraging the network at home in Africa as one integrated team. And I think if we take this message, I can assure you that a number of African leaders will resonate with it. Paul Kagame in Tanzania, in Rwanda will resonate with this. Many leaders of our African countries will resonate. But we have to really sell the idea that, especially now, at this point in the fourth industrial revolution, blended with some of the investments they've made, we can deliver some things in a political timescale in which we act as an integrated community and not as individuals. And when you do that, people like Obasanjo, like Kagame, leaders that really want progress for their people will invest in this.
In fact, concerning the strategy, maybe I can give comments, and I am not sure if you are aware about what we initiated recently, what's called the African Strategy for Fundamental and Applied Physics. It's not really focused on physics. It has also material science and the nanoscience. And in fact, the organizers of this meeting, I think he read an article I wrote about the strategy and the aims and objectives of our strategy published in Nature. And exactly, we are aiming, and what I wrote in that articles, which is the link is in the website of African Strategy. Exactly what you have said. So if you allow me to share the screen, I can just highlight few points about our strategy and how it is really related to what you are saying and what we are discussing today. So this is what we call the African strategy. African Strategy for Fundamental and Applied Physics. And this group, KTV from Brookhaven, and Simon from South Africa, Farida from Morocco, myself from Egypt, and Fayrouz from Algeria plus France, formed, and they are essentially the steering committee of this Africa strategy. And we are established since a couple of months, so the organization is almost complete now. We have international advisory committee from different important institutes, CERN, I think different African institutes. All these details you can find it in. I am interested now to go to the working group and to show you about nanotechnology and nanoscience, and also the material science. So we have about 16 physics working group here, including, as I said, let me go to material physics and medical physics. And I think we have condensed matter physics, and this includes as well nanoscience and nanotechnology. And really, I would like, and we would love that you can also contribute and share and participate with us in this African strategy by letter of intent or white papers about how we can really develop different disciplines, in particular in your fields, nanotechnology and nanoscience in Africa. So I don't want to take your time talking too much about the strategy, but this is just simple, not advertisement, but announcement, or trying to notifying you, I would say, that we are also trying to combine and collect all African institutes, African scientists to work together. 16 working group is really a lot. Each working group has subgroups and three conveners in each working group. So it looks like really we will have kind of serious cooperation and collaboration between African scientists. And in fact, this is not the first strategy we are inventing. There is European strategy in physics and different discipline. There is American, Latin American, and we were really motivated by all this previous strategy, and we said, yeah, also in Africa, we should really have some initiative like this. And the point is really not to write just a strategy for a couple of years. Hopefully it will be quite realistic, or even we should really dream in this to do some really good work, but really to establish for some link and some cooperation between African institutes and African physicists, scientists inside Africa and outside. And I think we are getting a lot of support from African scientists in Africa, outside Africa, and non-African scientists everywhere as well. So I invite you that really try to look at this strategy, and if you can cooperate with us in nanotechnology, maybe we work together to achieve some of the objectives that you mentioned today. Thank you.
Thank you for that, Prof. Khalil. We appreciate that. And that, I think, is that's a very good point. I think the idea of the need for fostering synergies across different groups and how to also, in the process of formulating a strategy, for establishing these new disciplines for nanotechnology. So I think that is a good point. And I think with many of our panelists here, the opportunity will be there. I think in as far as conversations that you may have online here and even offline, I'm sure as you exchange, these definitely that opportunity will definitely be there. I think there's one question. I think it's chat, yes, in the chat. I think it's from an anonymous attendee. Anyway, I think the question is that, or rather the comment should be, one area that stands to benefit immensely from nanotechnology is agriculture. However, as of now, not much work has focused on this sector. Perhaps there need to be agriculturalists and nanotech experts to team up and come up with nanotech products that will improve agricultural production, and especially for smallholder farmers in Africa. I think this is an interesting point, but I think in yesterday's presentation, I think we had Dr. Busiswa, who was actually talking about the role of nano fertilizers, and I think she was relating it to a point that Prof. Ngila had made, in the sense that there were one of the questions that comes up with the issue of nano fertilizers is about their safety concerns. I mean, how safe are they? So what I would do is I would probably direct the anonymous attendee. I think we'll try, and maybe if we can get if you're willing to identify yourself later, even offline, we can try and get your contact information and get you in touch with our friends from the Agricultural Research Council, who can elaborate a bit more on that. Or alternatively, you can also approach our panelists. I think even Prof. Soboyejo, who's also here, who has also spoken a bit about it in his presentation. He can possibly also give you a bit more of an answer there. So I'd like to say that. So I think that is a thing. I think I don't know if there are any more questions or comments.
There is another one in the question. No, it is the same.
I think I think it's the same one. I think
no, but there's another one. I think my questions to Dr. Martin, why the area is still called microelectronics. So did you see these questions?
Yes, I've seen this one. I think Prof. Thu has answered it, but I think I can still bring it to plenary if you'd want to maybe just answer it to the for the rest of us. I think the question, as you will have seen, of course, is about why we still call it microelectronics, and yet it's it's focused on nanoscale and also moving into sub-nanoscale. I think this is from Dr. Balakrishnan, I think from the Addis Ababa Science and Technology University in Ethiopia.
So as I responded to the questionnaire, it's more of a legacy issue rather than the technology. When we made the first integrated circuit, we made a microprocessor, because we're moving away from tubes to these really small components. And so that name has carried forward. And that's why we call them microelectronics. But if you look at the components we have now, the FinFETs are all in the nanoscale. So in reality, it should be called nanoelectronics, but there's a business side to it. There's a science side to it, and there's a business side to it. The business side, if you call it nanoelectronics, then you have to re-educate everybody about it. So the legacy issue is just a name that has carried through, not really on the technology. But also realize that although we are saying that the the components are nanoscale. These are packaged into bigger collections. Like the chip is bigger, like the BGAs are bigger. You can weld them, they're in the millimeter scale, but inside them they have millions and millions of transistors. So the consumer never gets to see that nano component or interact with it. Yep. But the name is all about legacy. It's not from the technology.
No, thank you for that. Thank you for that, Prof. Thuo. I think that has, brought clarity to that question. I think also, I think in relation to this issue, I think you would raise, one thing that comes to mind, or just I'm reflecting on your presentation on nanoelectronics. I think what I found particularly interesting was this idea of the amount of energy that needs to be expended as we continue. You mentioned the complexity, the increasing complexity and the increasing the sophistication which are needed, in order to produce, even smaller components for devices, be it computers, supercomputers, and whatnot. In your opinion, I just wanted to ask a question before I pass it on to Dr. Chigome, who has another question. How do you think we can resolve this energy, this particular challenge of harnessing enough energy? And I know Professor Beji had mentioned the fact that we've got a lot of solar, the capacity. I mean, the fact that we, 9 times out of the year, we have the most sunshine in comparison to the rest of the world. Is that a possibility do you think solar would be a particular avenue, as an energy source to allow us to participate within this process effectively? I don't know. What are your thoughts on that?
So the problem with the power, as far as electronics is concerned, is not just where we are getting from. We will hit what the market can allow us to use for computation. Whether we tap 100% of the production capability we have, we will have a problem. Because remember, the computational space or the computational consumption is only a fraction of what we do. We have to do production. We have to lay our cities. We have to do other things other than learn our computers. So even if we diversify our sources, the figure I showed was showing the human potential. What are we capable of producing? And out of that, if I can share that slide again. So what I was showing here is this is the planetary human energy production. This is what we can get, right? This is the yellow line is what we can get. If we continue the same way we are going, we will be requiring about that much of our production to go to computers and devices and little gadgets that we have. This is not feasible because our cars are also going to be demanding power from us, our houses, our cooking and all that. So no matter how much we produce, we're going to have a problem. So we cannot produce out of this problem. So the only solution is we have to find something that is manageable based on what we can generate from whatever resources that we can get. If we are at 100% production. So that's a problem. So the alternative here is not to try and produce more power. Otherwise, we're going to start using even means that are not very sustainable. But is to try and get into devices that are more power friendly. And the irony of it, if you think about it, if I have a chip that is doing the same calculation that my head can compute, but is spending 1,000 times the power to execute the same thing, something is not right with our engineering. We have space for improvement, and we can do that by looking for those new alternatives. Even though nature has had billions of years to optimize the process of neural computation, we can get something that is close to that. And I think that's what is driving neuromorphic computing, trying to mimic how nature computes or how the brain computes, and also trying to think about how we can do data filtering so we don't just spend a lot of energy holding on to data that we don't need. I hope that helps.
No, I think that that is particularly helpful. I see Prof. Geraldine and Prof. Paul Weiss have their hands up. I think if I may, I'll extend the floor to maybe Prof. Geraldine, since she was one of our next panelists, and then I can move on to you if you don't mind, Prof. Weiss.
Perfect.
Okay, excellent.
Yeah. Thank you. So my name is Geraldine Dantelme. I'm a researcher in material science and nanotechnology in France at the French National Center for Research. And I have a question regarding education. And this question is in the light of the work I've been doing recently under the guidance of UNECA. My work as a consultant was to design a generic curriculum in material science and nanotechnology for African countries, and specifically university that would like to develop and propose educational programs to their students in nanotechnology. And I have a question to Prof. Tuo regarding human capital. And I think we heard a lot about the fact that Africa has a high human capital, but we heard also that there is no critical mass of students educated in nanotechnology. Can Prof. Tuo, can you make a comment on that? I think in your presentation, you mentioned that it was important to also not always to have degrees, but to have people that would be able to work in the nanotechnology field. Yeah, I would like to have your opinion on that regarding this.
So yeah, a very, very nice question, and I'm a strong believer in hiring a skill rather than hiring a piece of paper. We have to differentiate between learning and education. And education is when we give people certificates, they satisfy what the university requirements are. That kind of system is important, and it's critical in actually benchmarking where we go. But there are other alternative ways of gaining skills, and that is in people who have done internship. If you look at the continent of Africa, the number of people who are in the tech space, technicians, you find somebody who has been a technician as a research institute for years, right? And these people have a tremendous wealth of know-how, but the fact that they don't have a master's or a PhD, certain doors are locked away from them. They're not on the discussion table when there is a design problem, right? But when there is an execution problem, we go to these people. If I take an example of a research institute I worked at as a student, we all knew who to go for when we needed a certain process to work. And this knowledge was passed through generation because these people are very, very good. So even as we design curriculums, they are curriculums that are meant for those high-level thinking, those people who will be kind of, the big troubleshooters. But there's another set of skill that will be acquired in a non-traditional way that we need to be aware of. It's harder to find. But if you do the work, if you use things, the tools are there. The business community has a lot of tools to identify talent. But we in the science community, we somehow tend to lean on, have you gone through the courses? Have you been certified? You have a degree program. And in the process, we might end up missing people who are very, very talented. The reason I pointed to that idea of focusing on the skill and not necessarily looking at the diplomas and the degrees is as Professor Ole mentioned, if you look at the institutions we have, how many high-level competent training can we do in the universities we have? And if you look at what Professor Swice was talking about, we do a lot of collaboration. A lot of that collaboration is not done at PhD to PhD level. Is somebody from the West, I go back to Kenya, I initiate a project, I have one faculty who's working with me, and we have a ton of technicians on the ground. When I come down inadvertently, I'm not transferring my skills to the most likely the people to be on the decision table, but I'm transferring to skills, my skills and my knowledge to people who will never be given a chance to be on the design table. So what I'm advocating for here is we have these diamonds in the rough. And this is actually a theory that has been really being pushed forward by a professor at Harvard, Professor Peter Breyer, who has been talking about these stars, people who have gained skills through non-traditional or alternative pathways, but they do have the skills to do something much bigger and they're much capable. And all we need to think about is identify them, enable them, and give them the platform to perform.
Thank you. Thank you for your answer.
Yeah, but I actually, if you don't mind, Wale, would you like to comment on that, on the skill power?
I agree wholeheartedly with this. And I think this whole idea of upskilling and just-in-time preparation of technical folks and bringing this concept of theory and practice into real sharp focus is I think, a major opportunity. And especially if you look at the population of Africa, where you have such large numbers of people not being able to go through the formal education system. I think what we have to do is to really tap into how we provide skills, real skills that people can translate to practice. And we need to leverage this medium that we're using today, because that knowledge can be obtained from anywhere in the world, right? And if it is focused in a way that connects to people that can translate to practice, we can really see the more immediate impact of this. So the only thing I would just add is that in all of this training, do it in collaboration with local people. You know, because with local people. So for example, if you're going to do a training in nanoscience and you have a Professor Swai or somebody else that's present, work collaboratively with them in delivering that training, because there's a certain focusing and shaping that goes on when you do that than when the ideas come totally from outside.
Maybe if I may just add a comment, that's true that we heard a lot about master or PhD students being trained in nanotechnology. And I think also training at the bachelor degree could be a kind of in-between and could also open up all these new opportunities for young people. Maybe, as you mentioned, not going for very high education through a PhD. I believe, as you said, many young students don't have this opportunity, but already having bachelor curriculum in nanotechnology, material science and nanotechnology could help getting people involved in this new field. I don't know, what's your opinion on that? But
it's an interesting one, actually, but I think there are two parts to it. One is nanoscience and nanotechnology, highly interdisciplinary. Part of the success of nanoscience and nanotechnology is bringing people from multiple fields together to drive the technology. And so it's how do you infuse that into different disciplines to bring them together? But I do agree that as these areas become better shaped, we may be at a point where you might actually have a discipline called nanoscience or nanotechnology that you can also pursue for different kinds of degrees, bachelor's, graduate, and perhaps different kinds of certificates that are modular and stackable. Yeah. And I think we're going to really need to think about the approaches that we can use to provide those different kinds of training to deliver the impact, right? So it needs careful thinking. And I do think that there is the possibility of having effective nanoscience undergraduate and graduate and technical programs that could generate that critical mass that we need.
So I don't know if Victor Conde is still here, but with the UNECA, we've been working on that over the last few months, and also with stakeholders of the field. So I don't know what's the time scale and everything, but maybe you would be interested in having a look at the document, and I'll be happy to discuss it with you.
We'll be happy to.
Yeah. Would be very interested.
Okay.
Yeah.
Oh, that's excellent. It's good to see, a lot of, this synergy and this exchange of ideas, and this mutual interest in each other's work, and this, again, the formation of collaborative networks actually happening here at the workshop. So that is really quite encouraging. I think, if I may, I'd just like to call upon Professor Weiss. I think he had initially also had raised his hand up previously, and then after him, we'll have Dr. Chigome to make a comment, and then I think we will break for lunch thereafter. So, Professor Paul Weiss, you are
very good. I hate to keep anybody from lunch, but let me just amplify what Martin said in terms of technical talent. A lot of the instruments that were developed for surface science, which was one of the main precursors of nanoscience, were developed by a technician at Bell Labs named Ed Shaban, who had an 8th grade education. He was caught up in World War II and sort of itinerant, and eventually made his way to Bell. And when you needed a capability, you went to him, and he would put it together and attach it to your instrument from design to building it. And people like that who have those talents are infinitely valuable. And if there is a way to develop more people like that by any means, that would be an extraordinary contribution, not just locally, but globally. The question I had was really for Winston, who mentioned the political timescale. And so I was wondering if he could comment on what the political timescale is, and if perhaps there's an advantage that you have where you're each prominent people in your countries with access to political leadership that maybe isn't so available to others in other parts of the world, and if there's a way that you can use those not only in your own countries but also to establish connections for the kind of international programs that you're trying to put together.
So, Paul, the political timescale is the timescale between elections.
Yeah, exactly. Yeah.
And if you are proposing a long-range plan that doesn't deliver visible outcomes between elections, it's politically dangerous to invest a lot of capital for many people. So you need to have a concept where at least the first phase of the impact is realizable between elections, because for the political types, what they invest in matters, right? They need to be able to show clear outcomes in terms of building capacity, building jobs, and you have to be very concrete about what you're proposing within the context of that. And that's my second point is, I think the collaborations that you do need to be built on this concept of leveraging and scaling. And so as you think about the complementary nature of the collaborations, it's really how you leverage each other to achieve scale and impact, right? And one of the beautiful things about, for example, the African Materials Network, African Materials Society, Research Society, it's a network of people that are within Africa and also beyond Africa. And we can leverage each other in a strategic way, right, to deliver impact in a short to medium term timescale. But over a significant period of time, we can then have group impact that diffuses across a continent. So I think from a point of view of formulating strategy for this group, think about things within a political lifetime of the key people so that as they support this, they can show the results and leverage the resources we have as a group and share those resources in ways that really promote synergy and scaling.
Very good. Thank you.
We have one more questions now from Anthony.
Yes, I think, okay, I'll let Professor Anthony Atama ask his question, and then I'll, I think it's directed to Prof. Wole again. And I think it's actually a comment, and his comment goes, I think we have something in common. Currently, one of my PhD students is working on a pro-diagosin, I hope I've said that well, extracted from Serratia spp. We are evaluating the drug for activity against TNBC, lung cancer and skin cancer using nano platform. How do we collaborate, sir? So I think that is his question to how to collaborate essentially.
We'll be happy to collaborate with you. Actually, at the moment we have probably about 20 different visiting scientists that are visiting our labs. We are working on prodigozine produced by different types of methods, and we're also working on targeted drugs for treating triple-negative breast cancer, which is TNBC, and other kinds of cancers. So I think the best thing is send me an email, and my email is public. You can just find it on the WPI website, and we'll be happy to talk. Thanks to this kind of medium, it will be easy to do so, and you're very welcome to collaborate with us. So please reach out to us. If you have any difficulty, work with Sam Chigome. He knows how to reach me. Sometimes it's not so easy.
Thank you for that, Prof. Wole. I think we'll just have I think Dr. Chigome actually had wanted to answer a question. I think it was a question initially, I think that had been asked by an anonymous attendee. So I'll leave that to Dr. Chigome to go ahead.
Yeah, thank you very much. Just a comment on the question about nanotech in agriculture. So we organized, I think, about 2 webinars, March and December last year. So I encourage the person who asked the question to reach out to me, or if you can see the email address here. This is a AMRS member, originally from Nigeria, but he is based at the Connecticut Agricultural Experiment Station in the US. I think there are probably about 3 of them who we've been interacting with extensively on nanotech for agriculture. I think one thing that I can just mention that is exciting about their work is that they use copper nanoparticles for most of their work. And I think, as you probably know, that we have quite a lot of copper in Zambia. And in terms of the value of copper on the world market, probably has gone really down.
Yeah, please keep doing that. I'll join you shortly. I'm stuck in a meeting.
So you can make use of probably that copper to solve some of the challenges that we have in Africa. So I'm happy to connect you and give you more information about this. And then I think the last comment that I have is that in terms of all that I've got questions, we're happy to link you up with Martin Chuo and everyone else. So at least you can see this interaction going on beyond the meeting. Thank you.
Thank you for that, Sam. Yes, I think that should be fine. I think, do we have any more questions? I think no. I think Prof. Atama has agreed to link up with. So I think, ladies and gentlemen, I think we will at this juncture take a short take our short lunch. I think, and what we will do, I think, is maybe we can resume at about 13:50. I think at that point that we'll have our next speaker, I think Dr. Brian Massara, who will be presenting making a talk on the foresight of nanotechnology and its contribution to Africa's sustainable development. And I think also this will be followed by Professor Emmanuel Yuha. So I encourage you all to join us again at 13:50 as we begin, as we go into these next two talks and the last our last session for the day.
Sorry, there's an end by Prof. Maza. I think he's got a quick comment.
Okay, no, that's fine. Please, Prof. Maza, please go ahead.
It looks like he's muted.
I would just to add some points in addition to the comprehensive presentation of this morning. First of all, in line with the policy, I think it's really critical to stress on the following points. One is furthering to continue to enhance the critical mass of fellows, which would be the workforce of tomorrow with a multidisciplinary background. Second one, it is necessary to introduce entrepreneurship skills in their training. And three, in view of the to embark in an initiative, a continental initiative from the academic side point of view, it requires the African Academy of Science as an interface with the AU, working closely with the UNECA and all institutions who are interested in pushing for the agenda of nanosciences and nanotechnologies. Because the African Academy of Science is an observer member of the AU. So it would be the ideal ambassador, therefore, if one has to work with it. Third one is to enhance the investment, to convince the policymakers to enhance the investment in science and technology above the 1%. Well, maybe to reach the 4%, why not? Rwanda has showed the case somehow. It's a small country, but quite a good investment in science and technology. The fifth point is to find out a possibility in embarking in EU Horizon type calls at the continental level, or at the beginning to start preferably with the regional funded programs. And the last point is to extend this nano training not only to postgrads, but to the bachelor level. Thank you.
Thank you, Professor Maza, for that elaborate and eloquent contribution. I think that is certainly something that will definitely give a lot of consideration, and so I think it provides a lot of food for thought for many of us on the panel. I think if time allows, after perhaps maybe in the last panel discussion after the talk, we can also, I think, extend any comments or questions from this session into that one, as of course it's an ongoing process and everything. I think since it all relates to nanopolicy and nanoscience, I think we can allow for that. So thank you for that, Prof. Maza. And ladies and gentlemen, I think we can proceed now to take our lunch, and then we can possibly return, as I said, at 13:50. So thank you.
So I think we're beginning to become successful at developing what we call brain circulation models. So the idea is that you don't necessarily have to go back 100%, but you can give back in different ways by going back to the extent that you can. And so at the African University of Science and Technology where I work, there are some people who come for a week to teach a short course, or a month to teach a module, or some people might take a sabbatical of up to a year to give back. And then there are others who choose to come back and spend the rest of their time in Africa. So the important idea is to allow people from the diaspora to contribute their knowledge to developing societies. So the truth is, Nigeria used to fund science and scientific research in the 60s and 70s, but then later on took away the mechanisms that provided funding for research. And through the intervention of UNESCO and the former president Obasanjo, the science fund was almost introduced, but unfortunately, it was never introduced. And I would argue that in spite of all the capacity that exists in Nigeria, we cannot have meaningful development until we really fund research that can allow 160 million Nigerians to do basic work that leads to innovation and applications of science. So we still need this, and it needs to be introduced for the full impact of research to have an effect on lives of people in Nigeria. For Africa to develop, you need a critical mass of scientists and engineers, which means that we have to figure out a way of educating a lot more engineers than we can. Now, in the absence of that, what you then have to do is focus on very high quality science and engineering. Because what you find is that 1% of scientists, usually the very best, contribute 99% of the innovations. On the other hand, if you want a critical mass that can really drive development, you need to have a massive investment in science and engineering education to produce that kind of impact that we desire in Africa.
The Botswana Institute for Technology Research and Innovation is a parastatal under the Ministry of Tertiary Education, Research, Science and Technology, established in 2012 to conduct needs-based research and development in focused areas.
We are an R&D outfit of the government. We are mandated to conduct research in view of transforming the economy, diversifying the economy.
The mandate of BITRE is to identify, develop and/or adopt appropriate technology solutions that provide sustainable, innovative solutions through co-creation and collaboration in line with national priorities and the needs of Botswana.
We do not want to be seen as saying that we know what people want. We want to develop our solutions with the end user in mind. That is our foundation.
Our mission as BITRE is to conduct needs-based technology research that provides sustainable, innovative solutions through co-creation and collaboration.
Obviously, as a mission, we want to be leading in providing those technology solutions that transforms the lives of Botswana and the region at large.
To achieve this mission, BITRE has gone to market to recruit highly qualified researchers in various fields of research to develop the right level of institutional capacity required to undertake any research work.
We went out through various corners of Botswana to ask the people what their challenges are. Then we took a whole bunch of those challenges and then we formulated our focus areas for this strategic period.
Our aim is to become an invaluable collaborative partner, working with partner companies from startups to large organizations and institutions to conduct joint research and solution development to address key problems facing our country. The organization separated into two main priority thematic research areas or departments. The first department is the Technologies Department, which consists of the following: Electronics and Communications, Information Systems and Technology, Energy. The second department is the Natural Resources and Materials Department, which is comprised of the Building Material Science Division, Climate Change Division, and the Nanomaterials Division. Technologies Department. The Electronics and Communications Division is a key division in the research and development of electronics and ICT-related technology solutions. This division aims to process efficiencies in all economic sectors, including but not limited to government departments, parastatals, non-government organizations, and private companies. The goal is also to be internationally competitive and to tap into the international market through innovation of cutting-edge and highly influential electronics and communication systems. One of the key projects of the division has been the development of the Sedin solar light, the first version of which was initially adopted by the Energy Division. The Sedin version 2, still in the pilot stage, is available in two levels of brightness, being the 2000 and 3000 lumens, and is power efficient due to the use of LED technology, adaptable to different conditions, durable and easy to install. The compact configuration of light enhances the integrity of all the components, including the solar panel, which is ordinarily prone to damage, theft and vandalism in similar competitor products. The light, unlike its earlier version, maintains the brightness all the time, therefore enhancing security and safety of users. The Sedin can be used to provide lights in public parks, communal spaces, schools, offices, shopping malls, clinics in urban and rural areas, and Meraka amongst others, even in areas that are not connected to the main power grid. The division is also working on more variations of the lights for various uses, as well as various projects that cover the fields of automated irrigation system with smart resource rationing, drone with infrared system for plant health inspection, as well as water quality and sanitation monitoring. The Information Systems and Technology Division. The objectives of this division is to develop and/or adapt software systems and mobile technologies to enhance processes efficiency, to create cloud-based data warehouse for storage of raw or processed data from economic sectors, to perform data or information processing and analytics for timely strategic interventions in areas such as cybersecurity, biomedical, education, agricultural, mining, transportation, and radiology. Energy is an essential part of life. The Energy Division is primarily focused on needs-based research and development of energy technologies to address the needs for both renewable and non-renewable energy resources for sustainable supply to the people of Botswana. As well as conducting energy research, the Energy Division also provides training and consultancy to clients on energy technologies. Under the Natural Resources and Materials Department, the Building Materials Science Division is the Research and Development Division of BITRI that is primarily focused on formulation of innovative building materials from natural raw materials and from industrial byproducts or raw materials sourced locally in Botswana. Climate Change Division is primarily focused on continuous understanding of the impact of climate change on Botswana's agriculture, water resources, and health sectors, which are key sectors of the economy of Botswana. Through the work of this division, BITRI aims to be at the forefront of understanding potential threats such as the risks of droughts, extreme weather events, increasing temperatures, vector-borne disease outbreaks, and changes in water availability, and develop innovative solutions to mitigate the threats posed by such natural disasters. The major research areas under this division are climate-proofing growth and development, climate projections, monitoring, GHG inventory, reducing GHG emissions, socio-economic effects of climate impacts and policy responses, synergies of reducing emissions and climate risk. By effectively minimizing environmental and economic factors impacting on the ability of rural farmers to achieve food security and limitation, such as poor access to markets, the division aims to develop an innovative adaptation framework approach to integrating climate risks into development planning. The Nanomaterials Division is the research division geared towards molecular level research and development of products, leveraging on the abundant molecular natural resources that Botswana has to address the needs of the people of Botswana. Nanomaterials Division, focusing on 3 research areas, namely filtration technologies, diagnostics technologies, specialty chemicals. As BITRI, we continue to be actively involved in seeking and establishing partnerships.
When you collaborate, you look at the benefit that you get out of a collaboration. Obviously, it has to be mutual. The person that you're collaborating with needs to benefit. You also need to benefit. Now, as a startup, new organization, we have partnered with various institutions around the world, not just in Africa, South Africa, USA, now we are taking to Sweden. These are well-established institutions that have already provided solutions. Now we collaborate with them so that we can take some of what they have done, we adapt it, and we make it a Botswana solution. So in a way, we want to fast track our getting to the market instead of do something from scratch.
We invite more local and international companies to collaborate with BITRI to utilize our facilities and turn Botswana into a nation that is strong on implementation of research-based projects that will significantly improve the lives of Botswana and the region. B3, Botswana Institute for Technology Research and Innovation. Technology solutions from you to us for you.
Greetings to everyone. Happy 60th anniversary to the United Nations Economic Commission for Africa. Today is a particularly important day for us, 60 years later, as the United Nations Economic Commission for Africa. We had a rather difficult birth, but I think that like all the other African countries, independence was a struggle. We finally got it, and 60 years later, I think that as ECA and as the rest of Africa, we can reliably and credibly say that this journey has been a productive one. Africa today is a continent that is much more developed than it was 60 years ago. I think in terms of democracy, pluralism, inclusiveness, we are doing much better. In terms of girls' education, how many women still survive childbirth, how many kids below 5 years old live past that age. We have done a lot. The numbers are impressive. And even though we still believe that we can do a lot more, and I think that a prosperous Africa is within reach within the next 2 decades, we need to do more. What do we need to do to get to a prosperous Africa? I think ECA has a big place and a big role to play as we go forward. Africa is changing, the world is changing. As we celebrate ECA's 60th anniversary, and it is a happy 60th anniversary because a lot is happening that is good. There is still a lot more that we need to do. We have youth, 30 million of them that are coming out every year looking for more jobs. We need to create those jobs. But then we have an amazing opportunity with the digital economy to be able to ensure that Africa's youth can find jobs, that they can be creative. We have an innovative continent. We have an innovative set of young women, girls, that we believe can actually be the determining factor for the next decade. We, as women, are not fully represented yet across Africa's economic tissue. We need to do more. That is why, as ECA, as we go forward with this new mantra of an ideas to action think tank, we are going to become hopefully one of the leading think tanks on the continent. We will be, ECA's dream is to become the leading think tank on the continent, that we can actually take a lot of our ideas to action and implement things that will ensure that women in particular become more empowered, that they find their place in Africa's economic tissue, that they find their place in Africa's political tissue, and that they find a better place in Africa's social tissue. This is an important part, we believe, at the ECA of the economic fabric going forward. Of course, we have other challenges on the continent which we believe that Africa is confronting. On the trade front, the African Continental Free Trade Area Agreement is, I think, the signature mark of Africa's 60 years, of ECA's 60 years, building one market where Africans trade with each other, where African culture, African innovation, African manufacturing, African industry, African services become one big platform, is really the dream of the ECA as we go forward. How can we do that? What is it that we will need to make a prosperous Africa? We need to work with our partners, the African Union, the African Development Bank, all other development partners whom we're very grateful have brought us here today, because we didn't come here alone. We came here based on the work of, again, an impressive list of former executive secretaries that have laid the foundations for what we need to do. I think with each executive secretary, ECA has only become stronger, and we hope that it continues to become stronger as we move forward. I think the path that each one has laid for ECA has been the right path and has taken us one step further and closer to our member states. And we thank our member states for supporting us. We thank our member states for being there with us when it was good and when it was difficult. We have been with our member states, and we can cite events like Ebola, we can cite events like being in the Gambia when it opened, we can cite ensuring that the G7 countries come into the CFTA in a way that ensures that we can do more trade. So I think it has been a win-win collaboration between the ECA and the member states. At the global level, we have worked really hard to bring Africa to the migration agenda and the migration discussion. We've worked very hard on illicit financial flows to ensure that Africa's voice is heard when we talk about global financial arrangements. We have worked extremely hard to ensure that when we talk about the laws of the seas, which is the next frontier in development and in exploration, that Africa's voice is heard in the oil and gas fields. We are working even harder to ensure that as we begin to embrace the digital revolution, Africa's data is protected. Cybersecurity as it affects Africa is also part of the global dialogue. Of course, Africa, like every other continent, is being affected by issues of terrorism, and we are also working in the global community to ensure that this does not endanger and hold back our growth. So I think at the global level, we have had good partnerships. We will continue to have those partnerships, but Africa believes and continues to rely on its regional strength and creating one single market, one single air transport market, free movement of people, ensuring that we can get our infrastructure from Cape to Cairo, Djibouti to Dakar in a way that our citizens can cross the continent seamlessly, remains, I think, the signature point of what ECA will continue to do to ensure that we get to this next prosperous decade for Africa in a way that brings more peace, empowers more women, ensures that our youth get jobs, more inclusiveness. The SDGs say that we should leave no one behind. I think that as we embrace Agenda 2030 and we work towards getting there, ECA is an integral part of the fabric of ensuring that the continent gets to Agenda 2030 in a way that leaves no one behind, in a way that ensures that we embrace both the agenda of 2063 and the African Union, which we know is seamless with Agenda 2030, and we ensure that we can bring these two things together. We would like to thank again our partners, the African Union, the African Development Bank, the regional economic communities, for having been with us throughout this period, and we hope that as we enact the UN reforms, the Secretary General's reforms, and we're very grateful for the support that every Secretary General has given the ECA over the last 60 years. I think without the support of the different Secretary Generals, and in my case in particular, the current Secretary General, Antonio Guterres, I think that the fact that he has himself shown leadership in ensuring that the ECA, the United Nations family in Africa, works very closely with the African Union to come up with a joint framework of work, and that he comes twice a year to ensure that this framework is actually implemented, we cannot find a better sign of leadership, a better sign of dedication to the continent. So again, with this support from the highest levels of the UN family, we believe that ECA's future is bright, ECA's future is strong, and we just need to go out there, think, act, do, and implement the reforms that we would like to put in place to ensure that Africa gets to the next decade prosperously. Once again, happy 60th anniversary to the Economic Commission for Africa, to all the staff, everybody who has been part of this long and interesting journey. Please stay with us for the next 60 years, and we look forward to working with everybody, our partners, former ECA alumni, former ECA family. Every one of us, once an ECA person, always an ECA person. So hope we enjoy ourselves today and for the next 60 decades.
The Agenda 2063 is a continental development plan for Africa whose achievement will lead to an integrated, prosperous and peaceful Africa driven by its own citizens and represent a dynamic force in the international arena. Agenda 2063 is committed to ensuring economic transformation that leads to higher standards of living for Africans. Improved education standards driven by a skills revolution founded on science, technology and innovation. Unity in society where democracy and good governance prevail and the universal principles for human rights, justice and the rule of law are pursued. Modern agriculture that leads to food security, improved productivity and production. Development of a blue ocean economy for accelerated economic growth. Protection of our environment and natural resources and the growth of renewable energy sources. Building world-class infrastructure across the continent. Establishment of functional and capable institutions supported by transformative leadership. a peaceful Africa where security and stability is guaranteed and guided by a fully functional and operational African Peace and Security Architecture, APSA. Promoting an African cultural renaissance embedded in the ideals of Pan-Africanism. Full gender equality in all spheres of life. African youth are engaged and empowered. Establishing Africa's own financial and monetary institutions that take full responsibility for financing Africa's development. Access to quality health services and proper nutrition for all citizens. An Africa that commands its place in global affairs, working with partners who will promote and support our economic development. Let us unite to build the Africa we want. Visit www.au.int to learn more about Agenda 2063.
Imagine a continent filled with limitless possibilities, where every African can realize their full potential. With the implementation of the continent-wide transformative flagship project of Agenda 2063, we can achieve this goal. An integrated high-speed train network that connects African countries so that we can travel and transport goods with ease across the continent. A continental strategy for Africa's commodities that ensures a collaborative process in developing and managing the continent's natural resources for all Africans. The world's largest trading zone in the African Continental Free Trade Area, which promotes trade within Africa and with the world. The African passport and the removal of restrictions through the free movement of persons, allowing Africans to travel, work, conduct business and live anywhere within their continent. A peaceful Africa where all guns are silenced. The Grand Inga Dam project will provide affordable and clean electricity. Improved and affordable air travel through a single African air transport market, SAATM, that connects African cities. An annual African Economic Forum that brings together great African minds to develop strategies to harness the continent's vast resources to the benefit of Africans. The establishment of the African financial institutions that promote economic integration and the transparent mobilization of resources to promote economic development. The Great African Museum will preserve and promote our cultural heritage and celebrate Africa's influence on the cultures of the world. Promoting cybersecurity that protects our data so there is safety online and ensures that emerging technologies are used for the benefit of Africans. An African virtual and e-university that provides access to the highest quality tertiary and continuing education to Africans anywhere in the world. A Pan-African e-network for innovative e-applications and
Thank you very much again, ladies and gentlemen, and to our panelists. I would like to introduce our first speaker, and that is Dr. Brian Mazara. Dr. Brian Mazara is the CEO of the South African Institute of Physics. Dr. Brian Mazara has done quite a lot of work. He has published extensively. I think he has also worked collaboratively with Professor Malik Maza, who is here with us. He has actually also done quite a lot of research in the way, particularly on the means through which nanotechnology can actually be commercialized, brought for market. Prof. Mazara has a Bachelor of Science honors from the University of Zimbabwe. He also has a Master of Science in Physics from the same university. He also has an MBA as well as a PhD actually in business administration. Without further ado, I leave it to you, Dr. Mazara, to proceed with your presentation on nanotechnology foresight and its possible contribution to Africa and sustainable development goals. Thank you.
Okay, thank you very much, Shingi. I think you can hear me clearly.
Yes, yeah, you're audible.
All right. This research emanated from discussions that we have been having with Prof. Malik Maza in terms of aligning business research with nanotechnology research, especially for the nano-AFNet as well as the chair in nanoscience at UNISA. So I'm going to talk about foresight in nanotechnology and maybe its possible implications for the policy that we are discussing about for nanoscience in South Africa. So my presentation, I'll have a bit of background into nanotechnology research and technology foresight. And then we actually developed a nanotechnology specific foresight model. Then we used that to look at the foresight perspective of South Africa. And then maybe emanating from this, we can make some recommendations for Africa and for this research going forward, for this particular seminar going forward. So I think this point has been highlighted quite a number of times, that scientific innovations create value and promote socioeconomic development and competitiveness. And we can give examples of the Asian tigers and the Silicon Valley, where science and technology has been used. And there is also the global shift towards knowledge-based economies. And for Africa as well, we want to move away from the resource-based and agricultural-based economies to knowledge-based economies, and there are different policies that are coming up in different countries. For example, in South Africa, we have got the NDP 2030, as well as now the shift towards the fourth industrial revolution. And one of the technologies that's receiving attention is nanotechnology, and it's an emerging field of science, and it's a general purpose technology. By general purpose, I mean there is no job that can specifically say this is nanotechnology. It is pervasive, just like ITC. It can be used in all areas or all industries and markets that we can think about. Then when we specifically look at the United Nations Sustainable Development Goals, there are several papers that have come out where nanotechnology can solve certain issues. For example, now we are grappling with the COVID issue. There's the nano-destroying masks, and I think in this discussion we've also heard about the Pfizer vaccine that is coming up, that is all nano-based. Then we have the issues of water and clean energy for photovoltaics and so forth. So in a nutshell, nanotechnology is predicted to drive the next wave of economic growth, right, worldwide. And the previous one was due to ICT and digital networks. And there is even an argument that the growth of electronics and ITC can also be attributed to nanoelectronics. I think the previous speaker who was talking about nanoelectronics and ICs highlighted that effect. So this wave here, we hope it's going to be driven by nanotechnology, and that's what a lot of researchers have said. And as such, most businesses and management schools cannot ignore nanotech. And now nanotech is also appearing in a lot of management journals. And maybe for Africa to be successful, we need to combine the two, not just the science, but also combine the R&D that is going on with innovation management. And from a business perspective, as I've already said, and from a science perspective, there's an exponential rise in R&D and a global race in nanotechnology. And by 2013, the market for nanotech was already over 1 trillion, and it was predicted to be over 3 trillion by 2020, creating over 6 million jobs. But as I've said, that nanotechnology is very broad. Countries cannot invest in nanotech across the board. So because resources are limited, our capabilities are limited. So we need to do foresight exercises in order to participate. Then technology foresight itself is the process of looking into the long-term future of science and technology and the economy and the society and the problems that we face, and look at those key strategic areas that have the greatest potential to result in socio-economic development. So maybe we can think, if we look at what we are discussing right now, to say, can we look into the future and address what nanotech in Africa can address, for example, in water, energy, health, and what are our capabilities and the capacity, and what are the scientific feasibilities of the technologies that we are doing at the moment. So in technology foresight, we actually predicting to say what are the possible futures, not one, but several futures. This is opposed to technology forecasting, where you are saying what is going to be the future. In technology foresight, we try to identify the possibilities that are there and then come up with strategies that can help us create the desired strategy that we want to achieve. And there are various methods that can be used in technology foresight, and the most used methods are those that are in black, the qualitative methods, like your scenario planning and so forth. But those have their shortcomings when you look at things like nanotechnology, where you might be looking at 20 or more options, and then to do 20 scenarios would be very expensive, right? So you find that in foresight in general, mostly the quantitative methods are not used, and the semi-quantitative methods, but they have advantages over the qualitative methods. Then in terms of the benefits of technology foresight, the first one is what I've already highlighted, to say it helps in a portfolio as a portfolio selection, to say which areas are you going to focus on. Secondly, it also helps in terms of policy formulation for governments, because resources are limited and they have political goals that they need to achieve, so they can use foresight as a policy formulation tool. So as a question for the Africa Policy Workshop that we are doing, do we need relevant Africa nanotech foresight processes to guide this discussion that we are doing? So it's just a question that I'm asking and we can ponder about. Then the other thing is in terms of awareness that was discussed, to say we need nano awareness as well as a glue to network the national system of innovation. As people carry out foresight exercises, they interact and then they know where they can contribute and they network and so forth, like part of things that are happening here. So in a nutshell, you also find that all industrious and developed countries perform routine 5-year technology foresight exercises. And yesterday we had the example of Singapore from Prof. White when he was presenting about the triple helix. So is Africa doing the same? And do we need to do that for nanotechnology in Africa? Now, when we looked at nanotechnology foresight research, there were two problems that we identified. The first one is that there was no effective technology foresight method that existed. And then we developed the analytical hierarchical process multi-criteria decision-making model that is specific to foresight for nanotechnology. The need for doing this is that identifying and selecting key research areas in nanotechnology helps a country to cost-effectively utilize limited resources by focusing and concentrating resources towards those areas that can bring socio-economic development. For example, right now, I think this team has focused on 4 areas: energy, food, health, and what was the other one? Health, energy, food, and water. Right, and then the next thing when we are looking at commercialization of technology, there are models for different areas, and then we identify that although innovation has been extensively studied, there is lack of models that specifically look at innovation management in nanotechnology. And that is where we developed the nanotechnology innovation diamond through literature review, and then we validated that through confirmatory factor analysis. And this model can be used to increase the rate of success of nanotechnology R&D projects, as well as project portfolio selection and foresight exercises. This is the model that we have proposed as the nanotechnology innovation diamond. There are publications that have come out of this. Maybe first of all, we need to understand and agree on the construct of successful nanotechnology. What do we mean when we say we have successful nanotechnology. One can think of publications to say you produce publications, patents, licenses, tech transfer, new innovations, new products, improvement of existing products, commercializations, startups, revenues, and job creations, among others. So what are the critical success factors that one needs to look at in order to produce successful nanotechnology? Right. The first one is the consumer needs and preferences. I think we have heard about issues of consumer perceptions of nano, the acceptance of nano, safety, ethics, and so forth. So initially, if you are going to do your research and it's not accepted, right, then you know it's not going to be successful. Maybe you can publish, but in terms of producing products and so forth, the acceptability of it. So what needs does it satisfy in the market that you can provide in terms of your technology push or technology pull that you want to do? So that's the primary success factor that one needs to look at when managing R&D in nanotechnology and nanoscience. The next one is industry and market hybridization. Like I've said, nanotechnology is not a standalone industry, right? It is a general purpose technology. That's why now we have nano energy, because we've got nanotechnology that is being used in energy. We have got nanomedicine because we've got nanomedicine that is being used in that. We've got water and all. So in managing nanotechnology, think of it as a general purpose technology, just like IT, to say right now we are meeting, but we are using the technologies of IT, but maybe when it was invented, that was not the initial purpose. So as a manager of R&D in nanotechnology, you need to think outside the box and say, this invention that has come, which other areas can it suit? For example, you can come up with a selective solar absorber. Where can you use it? Maybe solar energy, maybe in buildings, maybe in cosmetics even, for sunscreens and things like that. So you have to think outside the box. Then the next thing as a manager, we have identified, and most countries are driving for multi and interdisciplinary research. And nanotechnology itself, we have got nanophysics, nanochemistry, and so forth, nano engineering. So it's multidisciplinary by nature, but it has also got to be interdisciplinary. When you have many disciplines working together, there is success that will be coming out of it. And then that's where we also have convergence. Then in addition to the science disciplines and engineering disciplines working together, we also need to think about the innovation and business management there. And you find that most of the successful nanos that is coming out, they are coming from interdisciplinary teams. So interdisciplinary and cooperation is very important in nanotechnology. Then agglomeration is something that has also been identified as a critical success factor in terms of nanotechnology. Agglomeration occurs when several people with different skills come to work together in certain areas, and then they share resources, they share skills and things like that. And it has been observed that facilities are located within nano clusters produce more patents, they patent more, they commercialize more, they have more revenues than those working in isolation. Then the other thing is our capabilities. And one of the capabilities that I would like to outline there is scientist entrepreneurs. I think that has been highlighted. Instead of academic scientists, they say the scientist entrepreneurs are producing more. And do we have these for Africa in terms of our capabilities? Then the other most important thing is in terms of the innovation environment. We have the conducive innovation environment. Yesterday we heard about the triple helix, but for nanotechnology, it's the triple helix immersed within the consumer space because of these issues that we have said here. And also the public-private partnerships. For example, nanomedicine now for diseases of poverty is mostly funded by private-public partnerships because private companies cannot recoup all their investments in terms of those areas. So this is the model that we come up with, and then we had to test it using confirmatory factor analysis, and this research was done using a survey of nanotechnology experts in South Africa. We had 167 responses from that. And in terms of the results, they were reliable. We had a reliability, a Krobans alpha of 0.95 for the entire scale and for the different constructs that we were measuring. And in terms of the responses that we got, most of the researchers that responded are working as researchers, of the experts in nanotechnology are working as researchers and academics, and only 4% are engineers, and most of them are working in nanomaterials and nanoenergy. And in terms of the nanotechnology value chain, only 16% are working in nano-enabled products. The majority are working in nanomaterials. So is the low participation of engineers also affecting the rest of Africa? We might need to investigate, get that. And is the low levels of number of people working in nano-enabled products also affecting Africa? Because this is where the public and the politicians at the country gets the benefits when we produce nano-enabled products. Then the model was then tested using confirmatory factor analysis, and I would not dwell into this. This is the same model that was simplified, and it met the model fit requirements that were set. And then we also tested to say the hypothesis that all the critical success factors that we identified, the 6 are significant, and then we found that all of them are significant, and then they had a p-value of less than 0.01, which shows a highly significant. So that model was then validated. So we then had to use that in developing our foresight model. Then in terms of foresight, there is a research that was done by Popper, which contains that for you to be able to have new insights into foresight, you need to move away from mostly frequently used methodologies and use things like key technologies, multi-criteria decision-making, tech mining, and cytometrics, and also expert systems. So this is the direction in which we had to move. And then to do the foresight process for nanotechnology in South Africa, since 2006, when the South African Nanotechnology Initiative was done, there hasn't been a comprehensive evaluation of nanotechnology in South Africa. So we had to design the foresight process for South Africa. It was to determine the key list of nanotechnology areas for South Africa. That was the goal, and identify the initial list through literature review and policies and socio-economic policies of the country and what government wants. Then we performed tech mining of the publications using using Web of Science, and then we did a foresight-oriented cytometric analysis. Then we evaluated using the model that we developed and came up with a list. So now I'm going to just summarize the foresight perspective of South Africa using the developed model and maybe probe-related questions related to Africa. So using the Web of Science core collection, we used the Boolean search strategy developed by Porter and did data cleaning. We found that the number of publications in nanotechnology for South Africa increased from 68 in 2000 to 1,672 in 2019, which is a 2,456 increase that occurred. This was a higher percentage of increase compared to all other publications for South Africa that increased by 500%. But now we also wanted to do a patent analysis. We found that we got a total of 11,265 nano papers for South Africa during that period, but only 43 patents. And this highlights the DSI innovation chasm problem, where they're saying there's a lot of research that is happening, but not innovations coming out. We had only 43 patents, so patents were not analyzed in this research because it was going to bias the results. But maybe we can also ask for Africa, is that true? It's Africa patenting? And if not, what policy interventions are required? Then, given this high activity level in terms of nanotech in South Africa, to say it's outpacing all the other areas in terms of publication, we then wanted to compare with other emerging economies in the BRICS. And then we compared with India, China, and Brazil and Russia, and South Africa performs as the lowest of these BRICS. And then maybe what is the nanotech activity level of the other African countries, and are they performing better than the BRICS? It's something that we can investigate, and what can they learn from the other BRICS countries. Then in terms of those people that are producing, in South Africa, we found that most of the nanotech publications are coming from the academic institutions and the national research facilities as the second one. There is very low participation of private sector. There is only SASO that came up the radar with 0.21%. But we need to use nanotechnology for socioeconomic development. But now if private sector is not participating, what does that mean? What implications does that have for our policies? So we can ask a similar question for the rest of Africa. Is industry participating in nanotechnology? If not, how is that going to affect the rest of Africa? And what policy interventions can we come up with if industry is not participating in nanotech and it's only the academics who are doing it? Then the other thing that we looked at is the top researchers. We saw that for the past 20 years, the top 10 researchers contributed 21% of the publications. And for last year alone, they contributed 20% of the publications out of 30,000 that we have. So you find that the publications are skewed. Those who are producing tend to be extremely productive and the others come in 1 and 2. And if you look at these, there are new names that have come up in the last year and those that have been there for the past 20 years, which suggest there is some succession planning that is happening. Then you can also think from a policy perspective to say, for Africa, are we also having succession planning in nanotechnology? Then the next thing that we also looked at is, is the categorization system. We developed a categorization system for the publications that are coming from South Africa. We find that 34% is from chemistry and 24% from material science, physics 22%, and engineering 12%. These 4 subjects contribute 93%. And in 2019, there is now computer science coming up the radar. And maybe it's suggesting convergence and the 4th industrial revolution, AI, and so forth. And maybe in the rest of Africa, are we also seeing convergence? And maybe given the key areas that we found for South Africa, can we do a similar, maybe sort of exercise for the rest of Africa to see the key areas that are people are working on technology? Then, as I have discussed, collaboration is very important in nanotechnology. And we looked at collaboration in terms of authors as well as organizations. You find that most of the papers are written by 3 or 4 authors from South Africa, and there is only 2% of papers that is single authored. So there's a level of collaboration, but it quickly taps off around 7 authors, and it then comes to 0 there. Then in terms of institutional collaborations, you find that most of the papers are written by a single institution. But we said collaboration is very important. Why is this so? We think this is because of the DHET incentive scheme. For South Africa, academics receive a subsidy when they publish. But if that number increases more than a certain number of institutions, then government does not pay a subsidy. So is that also affecting nanotech research in South Africa and in other African countries and discouraging collaborations? And what can we do from a policy perspective to encourage large-scale collaborations? Then the other thing that we looked at is in terms of for international collaborations. These are key for nanotechnology research. We found that the top collaborating country for South Africa is India, and on the African continent, it's Nigeria. And if we look at 2019 only, we find that there is an increase in terms of collaboration between South Africa and the BRICS countries. And this can be maybe attributed to the BRICS policy that was signed by South Africa and the other countries. But in terms of intra-Africa collaboration, can that be improved? What is the level of collaboration in nanotech with other African countries? How can we increase it? Can we learn something from the BRICS collaboration for South Africa? Then we also then looked at the quality of publications coming from South Africa in terms of the citations that are coming up. You find that a quantity of publication doesn't necessarily mean the quality. You see here, communicable diseases has a low number of publications that came out, but the number of citations is high and the quality there is very high. So in terms of Africa, what are our niche areas that we are researching on, and in which areas are we excelling? Maybe it's a question that we can also look at. Then I've talked about the low number of publications, that low number of patents that are coming out. So to try and investigate innovation, we had to use the nanotechnology value chain, and then looked at the papers that were talking about nano-enabled products. And you find that medicine had the most number of papers talking about nano-enabled products. And I think in yesterday's presentation by Rocco, he also highlighted the same, to say medicine is coming up top in terms of innovations from nanotechnology. And then we had to compare South Africa with the other BRICS countries. We found that China here is producing a lot of products in terms of electronics, and then which seems to collaborate with the notions that it is the leader in terms of electronics export worldwide. So in terms of patents and nano-enabled products, what is the level in the rest of Africa? Maybe we need to look at that. Then we also came up with the nano oriented intelligence from the research that we did. For example, I'll just pick one area there to say, if you are looking at water, who are the top researchers that we have got? We have the top 3 researchers. Who are the top institutions? We have got them there. Which are the top regions for water research in South Africa? It's Pretoria and Johannesburg. Given what I've talked about in terms of location, if you want to be successful, most likely you have to locate in these areas. And then if it's for medicine, then you would do better in these areas here. Then in terms of collaboration, where do you look for collaboration internationally? It is Belgium and US for water. Then in terms of medicine, India and the United States. Then we can do maybe something similar to this for Africa, to say, can we get the nano foresight oriented intelligence for Africa in terms of health? Who are the top researchers? Which are the top countries? Which are the hubs that are working? Who is collaborating with Africa in particular areas? Maybe something similar to that can be done for Africa. Then this is the foresight model that we then developed using analytical hierarchical process. I will not go into that. And then this is the weighing that came from the models that we did for each of the different areas. We can discuss that. Then in terms of the areas that we identified using this analytical hierarchical process model, we decided to have a cutoff of areas that score 0.9, and these are the areas highlighted in yellow that will be top research areas for the different provinces of South Africa. To benchmark the model that was designed, we then also did a benchmark with an expert survey to say, of the different areas that are being researched in South Africa in terms of nanotechnology, which areas are critical, right? And this model here came out of the expert survey, where they rank in terms of scientific feasibility to say if an area is highly scientific feasible and it's of socioeconomic importance, then it's critical. But then you can give an example of a perpetual working machine. It has a high socioeconomic impact because you have free energy, but it's not scientifically feasible. So you cannot classify that as an area that is critical. So you find that most of the areas that were identified by the analytical hierarchical process were also identified by the expert survey, right? And those areas that were dropped, like your cosmetics and so forth, were also dropped, and we agreed on 70% of the areas. The only disadvantage of the scientometric side is that there are certain questions that you need to ask experts that you cannot answer using tech mining and so forth. So sometimes you need to merge the two. So in terms of recommendations from this foresight research and policy for Africa, maybe is it necessary to do routine foresight for nanotechnology in Africa to understand the status of nanotechnology in Africa. Where are we now? Where do we want to go in terms of the socio-economic needs, in terms of the SDGs? What capabilities do we have? What can we easily strengthen? What are the possible futures? And what are the low-hanging fruits that we can have? Then also identify the clusters of excellence. What clusters of excellence in the thematic areas, e.g. water, energy, do we have, and which countries and institutions, so that we don't do duplication and of results? Do we have fabrication facilities, shared infrastructure? Then in terms of collaboration, what are the international countries collaborating with Africa in terms of nano? Is there intra-Africa collaboration, and what policies can help strengthening it? Then in terms of the researchers themselves within Africa, who is collaborating with who, right? In which countries, institutions, and individuals? Then in terms of the skills, I think this issue has come up several times today, to say who are the experts in the different areas, and do we have the scientist entrepreneurs in Africa? Because from the literature that is there, they are the ones that are producing innovations in nanotechnology. And if not, what can be done to promote them? What policy interventions can be done? Then the fifth one is in terms of a think tank, to say, we said nanotechnology is a general purpose technology. It can be applied across many areas. So do we not need a think tank that can sit down and think outside the box to say, these are the innovations that are there, what are the areas that can benefit from this? And then in terms of Africa itself, what are our capabilities, what are our needs? For example, there's lots of mining taking place, and do we need to clean the acid mine coming out? And in terms of health and medicine, in terms of the indigenous knowledge, then poverty alleviation, in terms of value addition to the resources that we have got, and so forth. Then the relevant policies that can support nanotech. We saw that most of it is happening in academia. And how do we promote and move away? Because in terms of academia, what promotes you as an academic is your publications, not essentially the innovations that are coming out. What policies can be done? Then in terms of encouraging collaborations, then inter-Africa collaborations, do we need multilateral and bilateral cooperations? And then access to large scale shared infrastructure, and then innovations, patenting, and scientist entrepreneurs. I think I'll come to the end there, and thank you very much for the opportunity to share my thoughts and what we have been working on. Thank you very much.
Thank you so much, Dr. Mazara. I think you have given a very thorough overview and analysis in terms of giving us a broad understanding of the state of nanotech, not just across the continent, but also in South Africa, and as far as the types of research taking place, the types of collaborations taking place. And you have posed very pertinent questions based on your analysis in terms of the implications for policy, and not just for South Africa, but also for the continent at large. And I think you have given us a lot of food for thought. And I think, I hope it's something that we can, something that we in this session, we get to discuss further, and also have a lot of input. And I suspect there'll be a lot of, there'll be a lot of comments and contribution in regards to your presentation. I think we can proceed further now.
Welcome the panelists before we go into Q&A section. I'm sorry to inform you, Shingai had to leave because I think there are some classes he's teaching, so he had to step out a little bit. So I'm in charge until the end. Thank you. So I wish to bring in the first panelist, that is if I got your name correct, Dr. Tama, or if you may correct me, I'll ask you, give your brief bio, just briefly, then you contribute. Thank you.
Yeah, thank you very much, Dixon, for the introduction. I am Anthony Atama from the University of Nigeria, Nsukka. Actually, I am the director of Institute for Drug, Herbal Medicines and Excipients Research and Development at the university. But my base faculty is the Faculty of Pharmaceutical Sciences. And I have been involved in nanoscience and nanotechnology research as affects pharmacy and health since for more than a decade and a half. I did my first, second degrees in Nigeria, and then my postdoc in Germany, where I did nanotechnology and nanomedicines research. Yeah, without wasting much time, let me just give a brief overview of the presentations done by Masara and Professor Iwaha. From the presentation, it is clear that nanoscience is an integrating interdisciplinary science. It has aspects of biology, chemistry, molecular biology, surface science, biochemistry, engineering, and all this together. And not only that, it is an enabling convergent technology because it cuts across many sectors. It cuts across many sectors. You know, it is regarded as horizontal because so many industrial sectors make use of nanotechnology and enabling them to produce a product. And that's why it's also called an enabling platform, because the nanotechnology tools are used to launch products into the market. And also, it brings previously separated sciences together to achieve a purpose. That's why it's convergent. Brian was able to give us an overview of nanotech research in South Africa. But what you can glean out from that is that it's obvious that the intra-Africa collaboration is almost non-existent. We see those of us in nanotechnology, nanomedicine research, extending our hands, going to Europe, going to the US, going to India, other countries, collaborating, trying to collaborate with the nanotechnologies, nanosciences there. But within us in Africa, we don't have collaborators. People in South Africa are heavily into nanotech research. Research map produced, collaboration map produced. There was almost no collaboration between Nigeria and South Africa as far as health is concerned. I am Professor Malik Maaza in Nigeria and in South Africa. He has collaborators here in Nigeria in one of our nanoscience groups here. You could see in some of his publications, you see Professor Ezema. They are collaborating in chemistry, physics. But in core medicine, nanomedicine, we're yet to see collaborators. They will just do it alone. There is obvious need for us to bridge that, and then going forward will be how to bridge that gap using policies, and then extending our hands to our neighbors within Africa. Professor Iwaha also gave us a deep lecture on the nanotechnology activities as affects South Africa, and then what's the things that are obtainable in his laboratory. Yes, he provided so much insight into the nanotech research as a bridge between electronics, physics, and then health, because the convergent nature of nanoscience and nanotechnology has made it possible to use electronic approach to tackle health-related issues. You could see how we came from electronic background, sensors and the rest of them, to now bring it to health, where you use sensors to diagnose and use sensors to affect or corrections or correcting one thing or the other in the human system, and also to the treatment, also to guide the treatment. Diagnosis is very important and very crucial. This is correctly. That means the treatment will not get the right treatment, as exposed us to a lot of diagnostic tools being developed in his laboratory. These days, we want diagnosis to be as precise as possible, very rapid, so that it doesn't waste time before life is lost. So as soon as there is need for that, there is need to diagnose and let it be as accurate as possible.
As I said, my name is Anita. I'm a researcher at the School of Chemistry at Wits University, and I'm also a Royal Society Fellow. My research is mostly been focused on the use of nanomaterials for water treatment, and I focus a lot on mine drainage contaminated water. But I also have an interest, and I've carried out a number of studies about what the public perception of this approach is, because as I think we will all appreciate, public perceptions have the ability to make or break and influence acceptance of technologies. We've seen this in a number of different new technologies like genetic modification. And so part of my research, I straddle both legs of research as the technical aspects of developing nanomaterials for filters and for membranes, but I also do quite some community work, community engagements, and science communication based on public perceptions, risk perceptions, basically. The previous speaker has dealt very well in summarizing what has been talked about in the two previous sessions just before this panel, and so I will not go back very much into that. I would just want to point to all of us here the recent developments. For example, as I said, I'm a Royal Society Fellow, and there was has been a recent announcement by the UK government, for example, about cuts in order funding, so overseas development assistance, which has funded a number of collaborative research projects in Africa with the UK. And this has shaken the international research community, because then a lot of projects have been affected, have had to stop, have had to make significant changes because the cuts have been. And I just wanted to reflect on this situation and how it affects nanotechnology research in Africa. At the moment, South Africa and I suppose other African countries have a heavy reliance on EU funding for collaborations, for doctoral and postdoctoral training, conferences, and things like this. And I think this recent cut and how sudden they came and how severe they were have caused everyone to take a step back and think, how do we make our research on the continent sustainable in such an environment? It means we need to start looking inward, and how do we strengthen these intra-African collaborations that previous speakers have pointed to. We have to start to think about how we collaborate with ourselves and how we fund these collaborations between ourselves. And that also gives us the opportunity to determine our research agenda, determine our own Africa-centric research agenda. So, of course, when somebody else is funding, the piper calls the tune. So when somebody else is funding your research, you lose some level of, autonomy and decision-making in terms of what you pursue, how you pursue it, and who makes up your team and things like this. And so I think there is, in this misfortune of reduced funding or funding uncertainty, there is an opportunity for us to begin to look inward, to begin to think about the future and sustainability of our research and how we are going to take this forward in an environment that is very quickly changing and that has likelihood of affecting our research significantly. There is also the argument of patents and commercialization that was mentioned previously. And patenting, of course, is a very expensive process in itself. It's a lengthy and expensive process. And that might also contribute to why we don't see as much of it as we see in the rest of the world, in China and in Europe. And so we cannot just look at it from that single view that it's not happening as much. We have to think about also the downsides, the blockages, and what prevents this from happening. And finally, I also work on my research mainly looks at green nanotechnology and how we can begin to look at materials that are not only cheap or easily available, but also that respond to the new environment that we are in, using of waste materials for developing of the local solutions that we need. So, for example, agricultural waste that can be nanomaterials that can be created from local waste materials, and this will impact, for example, the affordability of our solutions. So, if we use very expensive materials, even if they're very effective, it might be beyond the reach of the people that we are creating them for. So, these are just the few ideas that I would contribute to this discussion, that we would go away thinking about how to make our research on the continent sustainable. So I would go back to intra-African collaborations, green nanotechnology, and how to look inward for funding sources. Thank you very much.
Thank you. You've got very stable network, Prof. Etale. We have one more comment from Mr. Freddie Woodland, if he's available, and he can just give few comments. Then we move to Q&A. Yes, Freddie, thank you.
Good afternoon, everybody, and thank you very much for the invitation to participate this afternoon. First things first, I should just establish that I come here very much as a layman. Nanotechnology is not our core business, the Commonwealth Security Group, but it is an area of significant interest. So first, I'd like to thank everyone who's spoken before me for certainly informing me and improving my understanding of the real scope of nanotechnology. And that's really where we first engaged with BITRE and with the concept of nanotechnology is how we can see the advances in this fascinating field be applied to security ends. Just dragging back to the Sustainable Development Goals that we've seen already this afternoon, very much the way that we look at security is in the round. Security for us is not purely focused on defense or law enforcement, but issues such as food security and health security, energy, all issues that we've already heard about today are very important. And without solving those issues, you cannot solve wider social issues and wider questions of stability. So they are the fundamental building blocks to any sort of security or stability. We presently have engaged with a project on emerging technologies and how these are transforming security, both for the positive and answering some of the problems of the past, but are also presenting their own issues and their own problems and how you go about safeguarding these new technologies. And this is how we've engaged with and taken ourselves into the discussion around nanotechnology. As what we understand is that nanotechnology has such a huge potential to help solve some of these issues around development, some of these issues around food security, health security, energy security, and then also, of course, in a more conventional security capacity. So really, I don't want to take up too much of your time in pretending I'm a nanotechnology expert. I'm certainly not, but I'd like to continue to listen more and be looped in with every one of you who sees this potential of nanotechnology, and we'd be very pleased to speak again and to look at ways in which we can help promote this cooperation amongst a community of budding nanotechnologists. Just as a final word, as an organisation, we look to promote security cooperation look to build partnerships in security, and we look to inform policy. And so, based on all those assets, we would be very interested in hearing from anyone that looks to use that platform to try and pursue those ends and their own. So, thank you very much indeed for the opportunity just to introduce myself and to allow me to convey my thanks to those that have come before. So, thank you.
Thank you. Thank you.
I look forward to speaking.
Thank you, Mr. Freddy. And of course, you are right. Security-wise, nanotechnology is an asset. And of course, we would wish to engage you further on how you can be able to come in. So it's time for Q&A from the Q&A panel. We've got a question from Peter Ndangili, and I think it's directing the question to all of us, but maybe to the panelists and the two speakers. He's asking, there are significant advances made so far in nanotechnology research. Are there matching technologies of handling nanowaste? So I think there is two of our speakers, that is Prof. Iwawa and Mr. Masara. And then we've got our two panelists. We may excuse Freddy for not being private to what nanotechnology is, but he can be able to give some contributions wherever or whenever he feels like. Thank you. So we start with Mr. Masara, then Prof. Iwawa.
Okay. Yes, there are, I think, standards and publications that are there, though it's not my area of specialty, but I think if you Google, there are quite a lot of discussions going on in nano-waste. In terms of Africa, I'm not too sure if there's anyone working on that. So I would pass to someone else.
Thank you. We may listen to Prof. Iwawa.
Okay, it's about around 2010, 11, 12. There was this buzz all over the world about nano code, because there was this interest on people started questioning, since this is new, we do not know the health hazards of these materials. So there was all sorts of, EU was setting their standard, but South Africa have, for example, South Africa Department of Science and Technology took it upon themselves, to develop nano codes, which were circulated. In fact, there were several workshops, but I think there are some particular institutes that took it up. I know some people in CSIR, and then National Institute of Occupational Health, I think is Professor Gilliman. She is actually the person who was taking it on. And then secondly, Professor Ndangili, you would understand that just like any other material, any other chemical material, there are standard procedures for handling chemical wastes. So it must be followed, particularly when we know the starting materials. So in addition to that, if your laboratory is standard, for example, in our laboratory, in our whole department of chemistry, there are standards of handling waste. So if you have that standard operational procedure, I think there'll be no problem in handling nano waste. Because there are specialists, there are certain containers to put them, depending on what it is, whether it's liquid, and then certain experts, professionals will come to collect them at specific days and dispose of them as scheduled for, as already prescribed for chemical waste. I don't know whether that answers your question, Professor Ndangili.
You can unmute.
Okay.
Hello, Andra.
Proceed.
Hello, Dixon.
I can hear you. Can you go on, please?
Okay, let me, I just want to add a little bit to what Professor Iwaha submitted. You know, in developing the value chain for nanotechnology and nanoscience, there is need for the developers to start initially, fundamentally, to think about how to handle the nano wastes. But I don't foresee that as a major problem since, like you mentioned, chemistry labs everywhere, standard labs have SOPs on how to dispose their waste. If radioactive materials, which have been in existence for quite a long time, there are SOPs for handling the waste and then destroying the necessary things, then the issue of nanotechnology or waste, nano waste will not be a problem. But it has to be, it's important it becomes a component of the value chain development of nanotechnology products. Thank you.
Thank you, Prof. Atama. You are free to raise up your hand. I have a question for Prof. Iwaha, and of course, this is in regard to the recent times, which is COVID times, COVID-19. We've seen in Germany there are real-time test kits for diagnosing COVID in school-going children, such that they have the self-testing kits developed already in Germany. Now, having spoken a lot about biosensors, is this a reality? Can we be able to have a situation whereby in Africa we can, because I don't see the technology being very different from what you're doing. Can we come up with our own diagnostics to improve testing for COVID-19? Thank you.
Professor Ndangele, you would know that most of the antigen and the antibody tests are biosensors. So they are either genosensors or they could be immunosensors. So it's easy to develop. But somebody, I've forgotten her name, the professor from Wits who just spoke during the panel. Sorry, my dear, I forgot your name.
It's called Anita.
Oh,
Anita. Professor Anita.
Yeah. Yes, and yeah, so yeah. Shushanta, sorry, Professor Anita, so I forgot it, I do apologize. So what happened is, you know, like she pointed out, it's a question of money. You know the story, I was collaborating with a Chinese person and they gave the Chinese person 6 million and they gave me 200 rand. 200 rand cannot pay my PhD student, so I don't know, 200,000 rand can pay my PhD student, not to talk about, you know, buying chemicals. So I'm just giving you that scenario. So it's all a question of money, because you could at least do your prototype before you start selling. Otherwise, you just stop at laboratory level. Those things are, in some other places where there's money, things are working, you know. So it's not difficult, particularly like I say, what we are doing, the method we are using, we're working with people in Belgium, is we are using, Netherlands, we are using we are doing after sensor for COVID. We're also doing nanobody-based sensor, which is a form of antibody, which is a form of immunosensor base, only that the immunosensor doesn't have the second chain. So, Professor, it is possible to get this done if we can raise the money and get people to be interested. One of the problems we have is you don't have venture capitalists a lot in Africa, so that's the point.
Thank you. Thank you. Yeah, I think you're very spot on, because we've seen the way China and maybe Russia, US, they're ready to supply both the diagnostics and the, of course, the vaccines. It tells a lot. It's more driven by venture capitalists or what we call money than helping cure the disease.
Professor Ndangili, the test in US is free, eh? The test is free.
But somebody somewhere has been paid. I don't think the government has paid for.
That's what I'm saying. That's what no, I'm supporting it. That's why I'm telling you that they have money.
Yes.
The guys have the money to do it. They're giving a lot of money to do it. So and they're supported. Right. Like the other, I think the professor, my other brother professor from Nigeria, he mentioned that over there, you see here you bring the product, people are ready to take it, government is ready to invest, but you don't see that one happening in Africa. You know, like we're depending on Pfizer, depending on other people. Why can't we try our own thing here? So, but that's a different talk. It's a different situation. Let's leave it for now.
For now, I wish to introduce. There's one panelist, Professor Agbaje. Maybe just give a few comments as we wrap up this session, and we go to the final session. So, if you have got any other pending question, can you put it in the Q&A, and we'll respond as we wrap up. Thank you.
So thank you. Can you hear me, please?
Yes, we can hear you.
Okay, please, thank you. Please permit me to stand on the existing protocol. I would like to make this presentation. First and foremost, I thank the organizers for inviting me. I'm going to be a unique person in this workshop because I'm a biologist. I trained as a biologist and as a microbiologist. And so when we look at what others that have contributed, we see that people have a background from chemistry, from physics, from material science, which happens to be the hallmark of nanotechnology. For those of us that were in Nigeria, I'm happy Professor Atama has spoken. The level of the nanotechnology research within the country is still very low and have been characterized with a low budget heading on investment in nanotechnology. If we compare ourselves with South Africa, from works that have been presented by distinguished Professor Iwoa and others, you will have seen that Nigeria is far South Africa is far ahead of Nigeria. And for those of us that were in life sciences, we also have issues of competence in developing capability in the area of nanotechnology. For instance, I started working in this area only in 2014 after I became a professor. So, but I have used different types of materials, and I'm trying to advance the course of nanotechnology in microbiology, and trying to establish the nexus that we have among basic microbiology, applied microbiology, and nanotechnology to give rise to microbial nanobiotechnology. And in our own little ways here, we have used different materials, enzymes, microbial enzymes, metabolites from arthropods, from plants to synthesize different types of nanomaterials, basically nanoparticles, liver, gold, alloy, calcium, titanium. And we have used them in the different areas that involve energy, for instance, in dust exercise, solar cells, in healthcare, and in agriculture. You can see some of the results of some of our activities using nanoparticles to degrade dyes, using nanoparticles as anticoagulant, and using it as a thrombolytic agent to lyse a blood clot. We have also used it to enhance the growth of a plant in heavy metal polluted soil. Recently this year, because we have found out that there are a lot of issues for those of us in the life sciences. You have a dearth of reading material text that will simplify nanotechnology and speak in the language that a traditional life scientist will be able to understand. I rallied some scientists in 7 countries in 4 continents to produce a 14-chapter textbook on the microbial nanobiotechnology. And as some of the speakers have said, my little effort here is that I have started introducing introductory aspect of nanobiotechnology to our undergraduate students in biotechnology course in their final year. And this has been stimulating. I've been able to do all of this because we have a multidisciplinary research group comprising of 11 members, engineers, biochemists, microbiologists, botanists, zoologists, and physicists. And some of the things that we have been able to achieve since 2015, producing papers, more than 100 articles, and we have a web presence. And we have been organizing workshops and conferences since 2017, training people on the rudiment of a synthesis of nanoparticles and some basic application of nanoparticles. We have also published some of the papers presented in these conferences in proceedings like IOP conference series in material science of the UK in 2020. We are collaborating with a lot of people, and I'm happy to tell you that we also collaborated with people in South Africa, particularly at the University of KwaZulu-Natal, Pietermaritzburg. We also have a collaborator in Egypt, Saudi Arabia. And through our efforts here, we have been able to motivate researchers in other universities within Nigeria. And we also do intervention programs for students of a primary and secondary school. We always invite them anytime we have conferences so that we catch them young in the area of this. Our own little effort is to also have a journal on nanotechnology, of which I serve as the editor-in-chief, Nano Plus Science and Technology of Nanomaterials. It was just launched this year. And another thing that we have done to popularize the nanotechnology in Nigeria is to make sure that our activities are covered by a wide range of media, newspapers, television station, even SciDev of the UK have covered our programs. And here you can see a picture of some of our activities in donor conferences in 2017, in 2018, in 2019, in 2020, despite the COVID, we had a huge conference, and we were able to get participants from different countries in different continents. So this is our own little effort, what we are trying to do here in Nigeria, working from Nigeria. We have a lot of speakers have talked about the challenges that we have in carrying out nanotechnology research. But this workshop is very, very important because it has enabled us to see like minds in other continents, in other countries, which I think we can collaborate with and benefit from their wealth of experience. Thank you.
Thank you. I think wonderful contributions. And I think we need to involve the stakeholders. And I think what Prof. Akbaje is doing is what we need to do to make the voice of nanotechnology felt across Africa. And I saw this initiative in South Africa, whereby nanotechnology is taught from basic, which is primary school level, to high school, up to now university. Any questions to Prof. Akbaje on to the other panelists and speakers as I wrap up this session? From the Q&A panel, there is none. There's no hand raised up. I wish to welcome, because of time, I wish to welcome the president of AMRS, Samuel Chigome, to take us to the next level and, of course, wind up this nanotechnology policy workshop.
Okay, thank you very much, Dixon, for taking us through that session. And thank you all for staying with us for 2 days. I think it has been a very productive time where we've discussed a number of issues. So I think what we'd like to do now, we want to get into the phase of closing and mapping the way forward, because I think from all these deliberations, we want to come up with maybe specific action items that we can focus on. But I think we all want development, but then we have to be guided by something. So what I'm going to do is try and probably maybe get people that can give us some closing points in terms of maybe what we should focus on going forward is a way forward in terms of all that we've discussed. I'll try to cover Africa as much as I can. So I'll start off with someone from North Africa, Professor Sheriff Dridi. If you can just summarize briefly, just some closing points, closing remarks, what we should take note of going forward. Professor Sheriff Dridi.
Yes, thank you very much, Professor Samuel. Thank you very much for the invitation and very interesting presentations from all the colleagues. And I will finalize by the end, if you like, because probably if we focus on sustainable development, we must, I think, adopt a sustainable or green approach of nanotechnology. That is what has been presented by our colleague Latif. And I think, for example, in our laboratory and our research center, we are using biomass-derived nanomaterials and apply them in agriculture, in development of sensors, biosensors, and also energy storage devices such as supercapacitors. I think the key word is sustainable approach, which will give rise to nanotechnology, low-cost nanotechnology, and sustainable one.
Okay, thank you very much for emphasizing sustainable development. If I can move on to West Africa, Professor Latif, if you can just give us your last remarks. Professor Latif, are you there?
Yes.
Okay, yeah, please, your last comments.
Hear me, please.
Yeah, please go ahead.
Okay. The workshop has enabled us to establish certain facts, and the high point there is that through collaboration we can achieve a lot of things within ourselves, within the country, within Africa, West Africa sub-region, and within Africa, through which we can raise a critical mass of specialists in this area. For instance, in Nigeria, where you have over 200 million people, I'm not too sure we have up to 1,000 scientists that are proficient in the area of nanotechnology that are practicing within the country. So we need a critical mass of experts there. And like what I mentioned earlier on, we need to introduce our students into this area early enough in their career. There will be need for us to re-engineer our curriculum in science and technology. And we also lay emphasis on entrepreneurship, on what they can do for themselves. Because at the end of the day, we want services and we want money from these enterprises. Thank you.
Okay, thank you very much for emphasizing the aspect of the critical mass. So we are also privileged to have the acting executive director of the African Academy of Sciences, and she's based out of East Africa. Professor Ngila, are you available to just probably give the last remarks? Okay, maybe while we're waiting for Professor Ngila, we can move on to the next person. I'll go to someone who can represent Southern Africa, Mr. Brian Masara. If probably you can just give your last remarks.
Okay, thank you very much. I think from the discussions that we are having and the primary goal of the workshop, it was to help with policy advice and obviously strategy for Africa. And there are key things that have come up like skills development, scientist entrepreneurs, collaboration and so forth. But I think the basis for us to come up with a strategy for us to be able to advise on policy is when we have information on the ground of what is happening. And I think a key factor to that is a foresight process, because it can be used for policy advice. You can use it as an instrument to then come up with your strategy and so forth. So I think there is need for maybe a periodic foresight exercise for nanotechnology in Africa to see what research is going on, what can address the issues that Africa is facing at the moment, what capabilities have we got in Africa, which are our niche markets and so forth. So we can maybe think in terms of the political timeline that we're talking about, to say, of those, what can be addressed within the political timelines of the people that are in office at that particular time. So I think from where I stand, a fundamental instrument that is required for the process that you are doing is a nanotechnology foresight process that can answer a lot of things. Thank you very much.
Yeah, no, thank you very much for that comment. And I think it also relates to even if you look at the way we do our research work, when we talk about even collaboration, it's also something that is also, I think, that has been coming out from a number of talks, that in some cases you find that people, they don't know what the other person is doing. So definitely, I think that aspect of foresight will help to clarify what to expect, and then also even in terms of the guidance of the political timelines, because I think lack of support, as you put across, sometimes it's because of lack of delivery, and then you probably don't have delivery because people are not very clear about the goals. So thank you very much for emphasizing that. It really helps to guide us. And then for the next presenter, it's not necessarily from Central Africa, but I'm just looking at him as representing the whole of Africa, Professor Maza. I think, as you know, that he is the one who's responsible for Nano AFNet, which covers the whole of Africa, where he works with quite a number of fellows from all of Africa. So definitely he has a very good understanding of the different regions of Africa. Prof. Maza, if you can just give your last remarks.
Thank you, Simon and colleagues. Again, I would reiterate on the requirement. What we have seen, somehow there is quite very progressive activities in the field of nano and pockets of excellence within the African continent. That is by sure. We are not lagging like in ICT or microelectronics and nanoelectronics, but there are quite a number of pockets of excellence all over the continent. And what is lacking is that the critical mass, we are not there. We have to ensure that the critical mass is reached. Second is that we have to have scientist entrepreneurs. So therefore, we need to introduce the entrepreneurship skills and innovation trainings within the syllabus. And third is that to push for enhancement in investment in STI above than the 1%. It is a requirement. And for such, the African Academy of Science is an ideal ambassador, because it is a member, it's an observer member of the African Union. Therefore, UNECA AMRS should interface with the African Academy of Science to push for this agenda for more funding, and therefore funding. And for funding, I think it would be ideal to embark in not a European type Horizon 2020 calls, but on a regional basis. SADC, for example, East, East, North of Africa, that requires not a huge amount of funding, but it pushes the local, the regional countries to embark in specific, nano programs. And also the necessity to extend this nano training, not to limit to the postgrad for the critical mass, but to start as early as the bachelor level. And of course, the technical component that was highlighted before. But what is sure is that we are not lagging. There is a hope that we will be moving fast, but it is this revolution that we have to catch, this train of the nanoscientists, of nanoscience and nanotechnology that we should embark in We should not miss this wave or this train. We have to embark. Thank you.
Thank you very much, Prof. Maza. Indeed, it's very important for us to look inward and appreciate that we are blessed as a continent. We have a lot of resources, but then we need to find a way of making take advantage of what we already have. I think the part where you're talking about introducing nano at the grassroots, it's interesting that what we did at B3 through our outreach program, we developed the comic books on nano, where we gave them to high school students and primary school students, where the sort of stories that are related to nano. So in a way, what we were thinking was that it's a way of introducing nano at an early stage, so that as they develop going forward, they then get to understand the more complex principles going forward, so that it becomes a way of life. So I totally agree with you that we have a responsibility of introducing a nano at the grassroots level, so that at least the contribution can come from all levels.
Thank you, Simon. Please allow me just to add on one point. I think that we are really lucky in a number of African countries that ministers or presidents are science and technology geared, very well informed. I think we should involve them in any of the activities related to nanoscience and nanotechnology. I think they are the ideal ambassadors, and they can voice for implementation of nanoscience and nanotechnology in the continent. So we have DGs, Director Generals, who are scientists by training, ministers who are scientists by training. I think we have to involve these policymakers in this endeavor. Thank you.
Indeed, I totally agree with you that we need to make sure that I think we start off by approaching those that we know have an understanding and will be supportive enough. And then once we have success stories with those, it will be much easier to then reach out to their colleagues. Yeah, thank you very much for clarifying that. Maybe just to check again if Professor Ngila is now available to give last comments. Okay, looks like
Prof. I want to give his hand raised up.
Okay, all right, okay. Yeah, please go ahead.
Chairperson, I just want to use this opportunity to thank Professor Maza for the enormous work he's doing, for the wonderful work he's doing in Africa through the scholarship he provides, both to many people from different African countries. I know so many, both old and young lecturers who have not had the opportunity to do research, whom he provided scholarships. So Malik, I'm using this opportunity to say thank you, because it's not, sometimes we don't know how to acknowledge people, when they're doing very great work, because many of them, their promotion, their livelihood depend on that access you gave them. So you understand what I mean, because there are so many of them. So I want to thank you especially for that. And I also want to encourage our people. Again, I also want to emphasize to everybody, don't try your best not to just depend. I know we're in many countries where resources are not there. Try your best to try to put something together locally in your lab. It's not every time you have to go to Harvard and come back. You come back and you come back to the lab where there is nothing. So when you're looking for grants and scholarships, look for those that will enable you to start getting some pieces of equipment. And also, you're also welcome to visit the lab, our labs, or do exchanges with the students. I told you that our lab has capacity to accommodate people. So those who have visited our lab know what I'm talking about. So thank you very much. And thanks again for organizing and for inviting me. And I thank all the 33 participants, and that's why I listened to your very interesting talk. I want to thank you. And then my fellow brother from South Africa who gave very interesting analytics of nanoscience endeavors in South Africa. Thanks very much. And thank you, Chairperson, for both the invitation and for organizing a very, very important and timely conference and workshop. Thank you.
Thank you very much, Prof. Yao, for those comments. I think it's a very strong point that you raised, and also it came out in your presentation. I think there's this saying that goes, if you have ideas, you can make anything out of nothing. So I think what you were saying that anyone can set up a lab. We just have to understand that it's possible to start with one instrument, as you gave an example of what you went through. So I think if everyone has that understanding, then definitely we should be able to realize that we all have a lot of potential to develop our labs. So I thank you very much for emphasizing that point. It is very important. Okay, so I think we have wrapped up that part of our program where we're just looking at the closing remarks. What we're going to do from our side is AMRS and UNECA. Probably I can just re-emphasize what I said yesterday when I was giving the introductory remarks, that the webinar or the 2 days workshop that we've had, it came up as a result of a program cooperation agreement between UNECA and AMRS on promoting nanotechnology in Africa. So we were focusing on how we can be able to influence policy for the promotion of nanotech. So we are going to put together the points that came up from all your presentations. And then what we'll do is that after we've compiled, we'll send them to you, so at least you can be able to also comment, because we believe this is a team effort, so that we can be able to then use that report as a basis for then probably mapping the way forward in terms of how we can be able to implement some of the things that we can prioritize and result in transformation that we're all looking for. So that's what we're going to do as a way forward from all these deliberations. And the thing that we're also going to do is that Professor Iowa, you just talked about the 33 participants that we have today. Yesterday we had more people, but then we know that there are a lot more people that could have joined. So what we now have at MRS, we on our website, we have a YouTube channel where we are going to upload the recording of our deliberations, so that we can have the rest of the continent have an appreciation of what I've discussed, so that we can be able to work together as Team Africa. We understand that I think with a number of Zoom meetings that people have, sometimes there may be quite a bit of fatigue, so you may not get all the participants, but it doesn't necessarily mean that people are not interested, but probably it's because of maybe too many classes that may be there. So we're going to work on our part as MRS to try and reach out to everyone who probably could not join us. So I think what I will do is that I will ask my colleague Victor Kunde from UNECA to probably give his comments just after, just before the vote of thanks, because our last component is of the program is a vote of thanks. But now what we're going to do is, as I mentioned, that we have a program cooperation agreement with UNECA. After this workshop, we have a boot camp that we're going to have around August. So my colleague, Professor Dixon Andala, is the lead coordinator for that workshop, or should I say the training program that we're running in August. He's going to just give you an overview of what our thinking is and the sort of framework and maybe what we hope to achieve from running that nanotech bootcamp. And also Professor Andala is the regional representative for MRS in East Africa. So we're working together, and he's also on the board of MRS. So we're working very closely with each other in terms of achieving the main objective of MRS, which is to promote excellence in all aspects of materials research on the continent. So Dixon, I'm heading over to you, so let's you can just give an overview of the nanotech bootcamp that is coming up. Please go ahead, Dixon.
Thank you, Samuel. Allow me to share my screen, please.
Yeah, please go ahead.
So I hope you can all see the slides.
It's not yet. I think it's still loading.
Still
Okay,
loading,
showing.
yeah?
Yeah, showing now.
Okay, thank you. As you've been told, my name is Professor Dixon Andala. I'm the regional representative for African Material Research Society, East African region. Part of the outcomes or part of what we are planning to do after this nanotechnology policy, we are planning to have a nanotechnology boot camp, and this is scheduled to be done sometimes early August. Of course, you realize the challenges we are facing currently because of the COVID. This will be done virtually. And the theme of the boot camp will be harnessing nanotechnology for sustainable development and rolling it to, of course, commercialization. We've got these various innovations which are offshoots from our research in the continent, which have not been actualized through commercialization. So our key focal points in nanotechnology applications will be one, energy, and that energy we are looking at solar energy, which include the photovoltaics, energy storage materials like the nano battery, and electrochemical research. We're also focusing on water. We'll be looking at nanofilters and of course remediation, environmental remediation for wastewater and acid mine water. We're also focusing on medicine, and medicine we're looking at drug delivery and nanoformulations, theranostics and biosensors. And then lastly, our focal area will be on agriculture. And in agriculture, we're looking at pest control, plant growth, and post-harvest technologies. So our target is roughly 100 students. And of course, we shall pick 20 best students from each region of Africa. So this includes West Africa, North Africa, East Africa, Central Africa, and South Africa. Of course, the ultimate goal for the bootcamp will be one, we shall undertake mentorship, which will lead to ideation. And of course, the successful teams will receive an award, courtesy of UNECA. And then we have got targeting key industries where we shall be having industry, partnership linkage between industry and research. And in this case here, we shall be aiming at technology transfer. And we are also having to have this bootcamp done once in every 5 years. And the other thing that we're also looking at here is we are looking at succession planning, because you realize from most of our speakers, right from Professor Wale, Professor Swai, Professor Iwoa, they need to pass the baton to the next generation of young scientists. And of course, through these boot camps, we are going to have mentorship and of course, identify very successful who can either go into innovation leading to commercialization or straight into research. So on logistics, we are planning between June and July, the registration portal to be open, whereby we'll be selecting the 100 students, 20 from each region. And the dates, proposed dates are between 2nd and 6th of August, 2021. We are already seeking funding and support from our partners. And of course, from this nanotechnology workshop, we saw Professor Rodrigo Martins for international, for AMRS, promising to support the event. We're also looping in Professor Paul Weiss from UCLA. Of course, he has also promised support. So anybody who's, apart from our key partners who's willing to fund this event, it will go a long way in ensuring that we succeed. From our panelists and speakers, we seek to request for volunteers, especially to mentor these upcoming nanotechnologists. And of course, those who are going to give lectures leading into ideation. And of course, this ideation of will lead into probably an innovation or innovative idea that can be funded eventually. And then we're also looking at ways of enriching this bootcamp through inviting distinguished researchers, the likes of Professor Iwoa, Professor Ngila, Professor Malik Maza, and anyone that is from the continent to be able to talk to these mentees and to be able to ensure that they shine and they succeed during the bootcamp. And then because nanotechnology is cross-cutting, we are looking at collaboration. And of course, we are looking here collaborations with other material research societies in Asia, Europe, South and North America. And then lastly, I invite you to probably give comments and probably enrich on how we're able to deliver this upcoming bootcamp. Thank you. And of course, let's have a discussion to see that our dream and our future for having nanotechnology realized in terms of commercialization in Africa is achieved. Thank you. Back to you, Samuel.
Yeah, thank you very much, Dixon. I don't know if there are any comments or questions. The floor is open. If you have any questions or comments, you can raise your hand or type in the Q&A. Professor Anthony Atama, please go ahead.
Yeah, thank you very much, President Africa Materials Research. Yeah, I want to use the opportunity to thank the organizers of this workshop. It's not easy. Hello?
Yes, please go ahead.
Okay, yeah, okay. Thank you. I just want to thank the organizers for the opportunity and to also mention that as aware of thanking the organizers, to also remind us that we need to continue post-study collaboration, intra-Africa collaboration, because that was what the point I wanted to make before my slides started. The connection started having problems. The intra-Africa collaboration is the key. We need to work together as Africa and then foster the development of nanotech and nanoscience and nanotechnology in Africa, so that we have a lot of resources, biodiversity that will help us achieve the ultimate goal of developing Africa. So once again, thank you for the opportunity, and I hope to continue to partner with the Material Research Society and the UNECA to see that the nanoscience and nanotechnology is developed. But in our own area in Nigeria, my school, we have programs. We produce MScs and PhDs from the time I started nanotechnology research. I produced more than 10 PhDs in nanotechnology. So we are doing a bit within this area, and I hope that we will continue to do that, God willing, and progress Africa in all ramifications. Thank you very, very much. Thank you.
Yeah, thank you very much for the comments. Indeed, we are going to make sure that I think everyone who participated will write to you, so at least we can find a way of all communicating going forward, so that if there are any additional comments that you have, at least they can come through, and we continue to work together beyond the workshop. I can see a hand from Professor Leslie Cornish. Please go ahead.
Thank you. I would just like to say thank you for organising this conference. And I was really sorry that this workshop rather, I was really sorry that I could not come to more of it, but I was actually from over a year ago I was already booked for these 2 days. But I'm going to carry what I did pick up, and as you said, you're going to summarize it back to the Arua Center of Excellence for Materials, Energy, and Nanotechnology. And I'm hoping that maybe we can help with the boot camp, but we'll talk about that later. So I just wanted to say that, and thank you very much. It was great to meet people online, even if I wasn't here very often. Thank you. Goodbye.
Okay, thank you very much, Professor Cornish. Indeed, I think what we'll do is that we're going to share maybe 2, maximum 3-page documents that just clarifies the framework of the bootcamp, just like what we're doing with the program for these 2 days. So at least you can get a better picture of what exactly we're trying to do. And then I think from there, you can then see how best to contribute. And of course, we're going to have interactions where we're going to organize Zoom meetings and discuss further to see how best we can work together for the benefit of Africa. Thank you very much. I can see there is a hand raised. Professor Swai, please go ahead.
I'm just wondering if the presentation will be on the website for us to go through. I mean, there was some wonderful presentation, for example, from Singapore, the triple helix and all that, or the one from Wole. Is it possible to put them on the website for us to go through?
Yes, so I think what we're going to do is we've been recording all the deliberations from yesterday. So we're going to upload on the YouTube channel, and then we'll request the presenters, all of them, if they are willing to share their slides. And then once they share, then we can then be able to share with the participants.
Okay, thanks.
Okay.
Thank you.
Okay, thank you. Any additional comments from the floor? Okay, if there are no comments for now, I would like to invite my colleague from UNECA, Dr. Vita Kunde, to probably just maybe say your last remarks before we then go to the stage of the vote of thanks. Vita, the floor is yours. Any last comments that you have in guidance from what we've been talking about?
Well, thank you very much, Samuel, and thank you very much to all the, I think, all the participants and the presenters and the panelists and for all the inputs. I think we learned quite a lot. I hope you can hear me. My thing says I have low, but anyway, so one of the, yeah, so from our side is, we're still not very clear on what it is that you really think we should be doing as a continent. And I think it's a question we haven't really answered. And perhaps all of us, when we go back, we should reflect on it again. Like, I mean, to just give an example, this round of work we are doing came from a very simple presentation I made to management. And I was not even talking about nanotech, actually, I was talking about something else. Then I put the publication we had on nanotechnology. And then the Undersecretary General says, what is that? So we talked about the work, and he said, okay, can you make the presentation later on when senior management meet? And then I made the presentation, made the case of why it's important for Africa. And then they said, well, maybe you should put a request for some money and see what we can do about it. And that's how all this this work was born. Because initially we've almost not really figured out on what it is that we want to do. So our question still remains, what is the big ask that we want to make to policymakers, something that we can take to industry players that we're working with? What is it that we can actually tell them if we gave us so much support, we could actually in the next couple of, I don't know, years or something, produce either so many people that are with this level of qualification, or we can at least maybe clean up some water that we can, even just we want water for schools, for instance, or for hospitals in rural communities. In a way, we make it very practical in a way that we can get partners. So yes, we can have our students work on things, we can have our researchers work on things, but at the same time, we have something to showcase that this is what we are doing. To just use an example of the other initiative we've supported over the last few years, when we started with biomedical engineering, everyone says universities will never agree to do courses in this area, and not to mention where the students work and the kind of questions. And today we train almost, I think we have about 3,000 young people actually doing their undergraduates, close to 1,000 doing their masters, and across, I think, almost 20 or so universities that have made it their own programs. So the question again is this an area where we can say we can support a number of universities to develop and integrate, for example, nanotechnology within the schools? Because I've heard when I was listening that why in some countries, I think you have these courses from primary school, secondary school, then why are we having a problem discussing it for undergraduates again, or for postgraduates? So perhaps we need to rethink, so is that the area we should focus, or is it in research in health? Then that we should focus. Then we can then support, we can then see how we can go about promoting. The second big thing is really, we have a lot of research going on, which is fantastic, but I think we have very little efforts going into quantifying what is expected out of it. And when we had the meeting on agriculture, and after we finished the webinars, and I talked to someone, and I'll repeat it again, I think, to everyone. There are our colleagues in the US who made that presentation would say, for instance, if you use your copper nanoparticles and you help in the growth rate of whatever your crops, and you save so much money from the use of, I don't know, herbicide or something, and then you will make so much money, the farmer will make so much more money than if they didn't, or if they used the traditional one. Now, the question we really need to do is, can we get to that level where we provide some comfort when we talk to policymakers, because that they can remember. The science, they will not. It doesn't matter how many slides we show them of how much science we did and what we can monitor with nanotech from space, but no one will remember. They will remember the science bit, but what is it that we can promise? Because that is what the politicians perhaps can easily sell, not only to the public, but also to themselves. So really, I want to leave that as some of the major issues I think all of us need to address. Because to then unlock some of the issues we are talking about, political will, well, what is it? It must be cultivated. It's not like the politicians also are smart, just that they have smart technocrats like yourself, academics and professors like yourself, who actually go and tell them, you know what, if we spend some time on this, and there is something we can showcase, and we can actually drive development forward. But if we just keep on to say, well, nanotechnology is important for development, and you listen and hear you, and then the question is, so what? So recently we had I had the same question again, Victor, what is your big ask in nanotech if you really want to do it? Because I was talking about these webinars we are having. And I told them, give me a month, I'll try and figure out what our big ask would be. Because we're doing the same for digital. What's the big ask? There we're starting to clarify what the issues may be that we can tell politicians to invest in digital technologies and advanced communications. Among the three major issues, for instance, access, cost, and then of course, quality and reliability and security. So basically we can tell some of those issues. So that's why to me, whether we have money or not, whether it's one person with one student working alone, which is, to me, that's fantastic. And I think learning from that lesson, I think the professor from Cape Town was talking about, starting alone with one lab, maybe one piece of equipment, and today they've fancy up. So perhaps there's potential for us to do quite a lot. So for me, those perhaps are really my major take homes, which is, what is it that we're going to ask about? Was listening to the colleagues from Singapore, perhaps that's what they did, which is saying, okay, we'll focus on water. And then, of course, the idea that the nanotech should not be looked at in isolation. So perhaps that's another area where next time perhaps we're having this discussion, shouldn't we have people from different areas of, and see, maybe we can meet with them to agree what would be like our common areas of common facilities, for instance, and what type of research, for example, we can do and use nanotech for now. That may not necessarily mean a product, but a service, like maybe studying the brain or working working with customers. People wanted to figure out how their customers feel about certain colors. So in a way, there's a lot we can do, and I think we're already doing a lot. Perhaps we need to figure out how do we communicate to policymakers, what is it that we wish to do, work with them. And of course, that brings me to the last point, which is perhaps we should also try and figure out which industry do we want to work with. Is it the industry that processes water, or that supply packaging for water, or should we work with the industry processing food? In other way, there are plenty of these areas where we can maybe use that for entry. I was looking at Iran's nanotech industry, and most of it is really in building. Materials like, what do you call them again? The stuff we put on our floors, tiles. They make nanotech tiles that have nanotech, and a lot of their research is in those kind of fields. So perhaps we need to just figure out what is it that we need to do, where about to, and which industry we can start with. And once at the same time, of course, we do our high-end research that may end up in many other products. So from our side, it really would be helpful if you can come back and provide a few answers of what is it that we should be doing, so that we can fold back in really good questions for policymakers. We can then have those discussions really serious at the AU. Otherwise, we go to the AU and we'll also have the same discussion. We have from technocrats within the AU doing the same discussion. We are having this SDG forum now within the UN at the global level, with all the agencies talking about all the nice things we are doing, and all of us figure out what is it that we report that's making a difference in people's lives with 9 years to go before 2030 arrives. So with those short remarks, I would wish to thank all of you for coming and help us to move, I think, Africa forward. All of us should really think brave. And I see you already there. And the rest of us will be here to support you. We used to be in labs. Now we spend most of the time wearing neckties for the same reason, which is someone should be on the policy side, arguing between academics or between researchers and between industry and with government. And if you can arm us, we would hope to try and see if we can do something. Maybe we can drive together the continent forward. So thank you.
Yeah, thank you very much, Victor. I think there's a way in which you always put across your points from an angle I think that is expected from your office. We appreciate that. I think it's very important what you put across, that we need to make sure that whatever we do, whatever comes from the lab, who is our customer? If we are saying that we want to solve a specific societal problem, the language that is understood by the targeted user, or who we refer to as the customer. For example, like if it's water that is not clean, all they want is just water that is clean. They may not necessarily want to understand everything else that is involved. So I think it also follows for the different sectors. So I think from my perspective, where we can find a way of having platforms for having, I think it's sort of like a multidisciplinary approach, where we can have a specific question that can come through, just like what you were asking just now. I think that can help with all our researchers, all our scientists, to be able to also see things in a different way, where everyone can then understand and maybe see things in a channel that is focused towards a goal that is very clear as the final output that is understood by our intended customer. So thank you very much, I think, for those points that are very important. So I think from our further interactions, as we write to all the participants, definitely we'll be able to get some diverse views. I think one of the things that we had hoped for was that over these 2 days, we would have a diverse group of, we try to invite as many people as possible, not only people that are specifically doing nanotech, but even some people that are new to nanotech, but there are people that are also concerned about the development of Africa. We try to invite all those people. But then unfortunately we didn't really get the participation that we were expecting. If I can give an example, the lead coordinator for this workshop, I think the one who was talking most of the time, Shingai Mtizo Mangiza, he doesn't have any background in nanotech. His background is in political science. But then he was one who was leading and doing most of the talking. So I think that's what we're looking at, that we are looking at how we can be able to impact society, not just to maybe stop at the lab scale. And then also what we would also hope for was that we would also get in maybe captains of industry, people that are involved in the commercial sector to also come through. Because I think for those, the language that they understand is the language of the numbers. So we'd hope that they would also come through. Unfortunately, we didn't really get the attendance that we were expecting, but I think we should not give up, because I think that's why they say that a journey of 1,000 miles begins with the first step. So I think the way I look at it is that we've come together over these 2 days, and we've discussed, we've raised some questions. So I think we just look at how we can be able to move forward for the development of our continent. So I think with those last words, I just want to thank all of you, to all our panelists, to all our speakers, and then to all participants that have been with us for these 2 days. We thank you very much for the time, and we look forward to continue working together for the development of our continent. Thank you very much. I think by that I can then declare that we have come to the end of our 2 days workshop. Thank you to all, and stay safe. Bye-bye.
Thank you. Bye-bye.
Okay.
Bye.
Bye-bye. Okay.
Bye-bye.
Thanks all.
Bye, everyone.
Thank you. Bye, everyone.
Bye-bye.
Bye-bye.
Bye.
Okay.
Bye, everyone.
Bye.
I'll just play some videos.
Yes, that's in order. Bye, Prof. Ngila.
Products and services, and the Encyclopedia Africana, which will document and celebrate Africa's history, culture, and the contributions of African people throughout the world. Let us unite to build the Africa we want. Visit www.au.int to learn more about Agenda 2063.